Hello and welcome to #Learning Courses. My name is Sai and this is the Terraform Masterclass for AWS Beginner to Pro. Now, first of all, I want to thank you all for taking your time to check this course out. And I want to begin by giving a brief introduction about myself, and then I will go and walk you through what this course offers and what you'll get by the end of this course. Now, like I said, I'm Sai and I'm a cloud solutions architect, and I've been architecting in the cloud for a long time now, and I'm an AWS certified professional, and I hold all the 5 AWS certifications. And let's begin by discussing about what Terraform is and why you need to learn Terraform as a cloud practitioner, right? So Terraform is one of the very critical skills because it is a platform for you to write your infrastructure as code and easily manage. And one main important advantage of Terraform is that it is cross-platform, and you can have several cloud providers integrated into your single code, meaning if you have multiple workloads which are provisioned in multiple cloud providers, then Terraform is one way for you to unify them all and bring it in under one particular script or one particular project, and you can save them all in your source control and use it to manage your infrastructure. Now, why should you take this course? Because I have put in a lot of information in this course which I have gathered in my journey of cloud architecting, and I've taught you all the skills that are really important, and some of them you even might have not found it in the internet by searching it, because I've found few ways of using things in Terraform which are really useful when you're having multi-environment workloads. So I've put in all those information in this. Now let me give you a brief introduction of like what this course curriculum would look like. So we'll start off by giving a basic introduction of what Terraform is. I'm going to walk you through how to install Terraform, how to create your project structure, and like what are the different components that go along when you create a Terraform project. Once we go through that, then we go ahead and create some of the basic things like variables and inputs and outputs. Once we finish that part, we'll go ahead and provision some of the AWS resources, right? So we experimented with S3 and EC2. And once we get hold of how you work with the AWS provider and how you can create some of the resources, we'll go ahead and learn the some of the advanced topics of the Terraform, like modules and workspaces. I will show you there how to create variables which are specific to environment across different workspaces, and I will also teach you how to use shared variables concept across multiple modules that you can leverage in your infrastructure. Then once we cover all those basic advanced topics in there, I will go ahead and teach you how to create a two-tier application in AWS, and that would be a complete project of creating multiple environments, creating security groups, launch configurations, autoscaling group, load balancers, and so on and so forth. It is I've covered most of this stuff in a hands-on way. So if you guys follow along with me when I'm going through different parts of the course, you'll really benefit from practicing it along with me. And this particular knowledge of Terraform and how to do things in the cloud will really take your career to the next level, because in every interview or in every company that you go, the first thing they will check if you are a cloud practitioner is like how you are managing your infrastructure as a code. And when you say that you know Terraform, then you really have an edge in getting that new job. Or if you're already in a cloud practicing job, then it will really take your career to a next level, because it will really help you to manage your infrastructure in a very very efficient way than just going ahead and provisioning things manually. So I'm really looking forward for you to join my course, and I will be here to help you out with any questions that you might have. And I really do think that you will not waste your money or time by going through this course. So I'm really hoping that you will continue and come along and join the course, and I will see you there. Thank you so much for watching. Hello and welcome back to another lesson of hashtag learning courses, and in this lesson we are going to see what is Terraform. Now I know that all of you are here for Terraform because this entire course is designed around Terraform, and I felt like I need to give a little bit of introduction of what Terraform is, and give you a walkthrough of like who developed it, what is the website, how does it look like, and what do we get out of it, and how are we going to use it to build our infrastructure. Now once we get a quick introduction of what this is and like the quick walkthrough of the website, we are going to like go in depth of like what is infrastructure as a code, and what exactly I mean, like how to install Terraform, like how to set up your AWS, and so on and so forth. So if you already know what Terraform is, you can just skip this lesson. This is for someone who really don't know anything about Terraform. We're just going to get a start from like absolutely like taking a perspective of the student knowing nothing about Terraform. So that's it. Let's get started. So first thing is Terraform is a infrastructure as a code tool, meaning you are going to script your entire infrastructure. That is going to be your it may be your AWS resources, or it could be any objects that you want to put in S3, or anything that is related to your infrastructure, that you're going to specify it in a form of a Terraform script, and you are going to save it in a version control or wherever you want to put it in a secure place. Now in the next lesson, I'm going to show you, like I'm going to tell you what is infrastructure as a code and like what exactly you get out of it. But in this lesson, let's just go and take a quick look at the website itself and see what Terraform is. Okay, so this is how the Terraform website looks like. It is basically www.terraform.io, and Terraform is a open source tool. So basically it is free for you to use, and it is developed by HashiCorp. Now HashiCorp is a kind of a very good community contributor in terms of any any tools that are like used in cloud applications. You can check out like the other tools which HashiCorp offers. There are tools like Vagrant, there are tools like Packer, which are used for different purposes. Now Terraform is basically a infrastructure as a code platform, which allows basically you to write, plan, and create infrastructure as a code. Now well, why do we need Terraform? Like you could argue saying that AWS provides CloudFormation, right? So CloudFormation is another infrastructure as a code tool. Now if you're hosted completely in AWS, you kind of get a question like, why do I need to use Terraform? Like why not CloudFormation? Now to answer that, CloudFormation is basically you're tying yourself into AWS, and what Terraform does is it gives you an opportunity to kind of have your infrastructure open to a multi-cloud thing, and you can always have like, I mean, you can always have the same Terraform code, and you can add more components from other cloud providers. Like let's say you have resources like EC2 instances or whatever from AWS, and you want to use some other cloud services like Azure or any other cloud provider. So basically you can have everything set up in one place, and you can use the same tool to kind of organize your entire infrastructure. So that is one of the benefits of using Terraform. It is cross cloud platforms, and it is kind of easy to use. Now you must be wondering, like, what is the language that I'm going to use to write this Terraform script? It is basically HCL. It is called HashiCorp language, and it's kind of more of a declarative language where you're going to specify, okay, I need AWS EC2 instance with these and these properties. It is quite simple, and it is like any programmer, or like even I would say, like, even if there's no past programming experience, you could easily get around and get hold of this writing a Terraform script. And I'm going to walk you through the different different steps that will be I'll be walking you through like all the different components of this terraforming scripting, and I'm going to show you exactly like what is the best way to do it. I have used Terraform in all my experience, and then I've figured out a lot of ways which are actually not documented, and I've kind of have techniques around like workarounds for situations which are not natively supported by Terraform, like using variables like in a different way. I've experimented a lot in Terraform, and I'm going to show you a lot of things. So this is a quick introduction of what Terraform is. So now we can stop our lesson here. I'll just allow you to go ahead and visit the website, check out the documentation or like whatever the guides that you want to see. You can read through all of these. I don't need to like just read through or like explain what it does. So basically, like I said, Terraform is an infrastructure as a code tool, and it gives us a lot of options, and you can use the same tool for different cloud service providers and so on and so forth. Now I'm going to stop this lesson here, and we in the next lesson we'll see more about Terraform and infrastructure as a code. So thank you for watching, and I will see you in the next one. Hello and welcome back to another lesson of #learning courses, and in this lesson we are going to see what is infrastructure as a code and why do we need it. So in the previous lesson we have taken a quick look at what Terraform is, and we have seen like who developed Terraform and like how the website looks like, and what language do we need to learn for this, and like a brief introduction. Now, in this lesson, let's take a step back and let's analyze like why did HashiCorp even develop a tool like Terraform? What is the problem that they are trying to solve? Now, if you think of it, the problem here is basically, let's say you have a cloud infrastructure. You have, let's talk about AWS. Now, most of you know like some of the AWS resources like load balancers or EC2 instance or autoscaling groups or S3 buckets, any of that. So what you usually do is like you go to your console, you open it up, you walk through the different wizards to kind of create your resources like load balancers or EC2 instance or whatever it is. And let's say if you're doing a simple task, that is fine. But if you are actually working on an enterprise application, or if you are like building a huge infrastructure for your company, then you need to keep track of each and every resource that you create. And you need to know exactly how you created it. And it is nearly impossible for anyone to remember why they have created a particular resource and what is the reason for it. If you ask them like 6 months later, when they are like moved on to some other project, and then they go back and like try to think, why did I even create this? Like, who changed this? That's another thing. Let's say if multiple people are managing your infrastructure and you go back and see, this is not what I've configured. This security group, I've never opened this port. Who opened this port? Can you go back and check? And can you go back and track it easily? Can you go back and fix it? Like, do you even remember what it was? So these are the problems that a typical administrator or a typical AWS guy or any clouds guy will face in his day-to-day job operations. Now, using Terraform, like not only Terraform, any other infrastructure as a code, basically here what we are trying to solve is trying to keep track of what resources we are creating, who created what. And now when you have infrastructure as a code, now let's say you script saying that, okay, I need a load balancer, I need an EC2, and I need a security group, and here are the rules that I'm going to put in this security group. Now all those rules that you specify in the security group, and you run that script, your resources are created in your cloud environment, and once they are created, what you would do is like you would just check those changes into any version control like git or subversion. Now once you do that, what you're doing is basically keeping track of saying that, okay, today I've created these particular resources in my cloud, and this is the reason that I've created it. You log it in your commit message, or you can even throw in some comments in your Terraform or like any infrastructure as a code document. And later, if you like go back, like come back to it after 6 months, then you know exactly why something was provisioned in a certain way. So that is the main problem that we are trying to solve. So we want to document what we are creating, we want to know why we are creating, and we want to keep track of who created stuff. And not only that, now let's talk about handling multiple environments in your infrastructure. Let's say you're working for an enterprise company. Typically they have like dev stack, QA stack, and production stack. Now let's say you have created a stack for a specific application, and it needs like load balancer, autoscaling group, security groups, whatnot, right? So you go ahead and create it for dev stack. Now let's say once dev stack is all done, everybody liked your application or your infrastructure stack, and they want to promote it to pre-prod or like QA or production. Are you going to go and like run are you going to go ahead and like create all the stuff that you have created manually in a different environment? How much time you are spending there trying to recollect? And it is not even guaranteed that you're going to create the same infrastructure that you have created there, because there are so many little things that you might actually miss when you're configuring the cloud infrastructure. So this infrastructure as a code also solves this problem, because now what you're trying to do is like basically you're saying you'll change certain parameters in your code, which is like pointing to different security groups or different, creating it with a different name or something like that, and basically you're running the same infrastructure, same code that you have used in dev, and you're replicating it in QA and production. Now you're saving time, you're making sure your infrastructure is like same across different environments, which is really essential, right? So if you're testing some certain security issue and your dev is different from QA, is different from production, then how are you going to figure out if there is a issue which is in production and if you see no issue in dev or QA? So these are the kind of problems that we are trying to solve using infrastructure as a code. So now that we know like what and why infrastructure as a code, now let's talk about like why to choose Terraform. Now Terraform is a amazing tool, and it is loved by all the guys that are working in the cloud, and I personally love it, and I've been using for more than 2 years now. I use literally Terraform for every AWS operations that I make for provisioning any resources in AWS. And basically one of the main reasons why people choose Terraform is that it is a cross-platform. Now let's say you have an infrastructure which is scaling across different clouds, multi-cloud infrastructure or hybrid cloud, things like that. So Terraform supports many different cloud providers, and you can have all of them scripted under the same Terraform file. You can target different cloud platforms, and it is easy to manage, easy to learn, easy to kind of maintain. And there are different strategies that I'm going to discuss in the coming lessons, like having the remote state files. I'll get to that specifics of like advantages of Terraform as and when we come to those topics along the course. So I really hope that you got a good understanding of like what is infrastructure as a code and why we actually need this. I'm going to stop this lesson here, and in the next lessons we are going to continue more on Terraform, the installation and the setup part. So that's it for this lesson, and thank you so much for watching. Hello and welcome back to #learning courses, and in this lesson we're going to take a look at all the requirements for this course, and let's get started. So the first thing that we need is, of course, we need our Terraform software to be installed, and once we have Terraform software installed, we need a AWS account. I mean, like, we are basically in this course we are covering a lot of AWS things, and to kind of do the examples that I'm showing you here, you would need an AWS account, and you need to set up AWS credentials by creating a user, and you need to set those credentials in your local system, and for editing the code itself you need a code editor. It could be a Visual Studio, or it could be a Notepad++, or it could be a Sublime version, Sublime editor. That's up to you. Whatever the code editor you want to use, it's fine. And then last but not the least, you need an OS of your choice, which could be a Mac, Windows, or Linux, whatever the system that you choose to. So that's pretty much about it, and in the next lessons we are going to go ahead and install all the required software and make our system ready, so that we can go ahead and do some cool stuff using the Terraform. That's it for this lesson. Thank you for watching, and I'll see you in the next one. Hello and welcome back to #learning courses, and in this lesson we are going to install Terraform for our course, and let's get started. So the first thing that you would do is basically go into your web browser and just key in www.terraform.io, and you'll be landing onto this site. Now all you got to do is go to the downloads section here, and then select the OS that you are currently working on. Now basically this is not a installer like a typical Mac or Windows installer. It is just a zip file that you're gonna download, and you gotta configure your path variables to kind of figure out like what Terraform resolves to, and that's pretty much it. So let's do this for Windows, and it is pretty much similar in all the other operating systems as well. So let's go ahead and download it for Windows 64-bit. I'm currently working on 64-bit. I'm gonna create a new folder here saying the Terraform latest, and inside this I'm just copying this path, and then I'm going to save it here. So once that is downloaded and saved, the next thing that we are going to do is go to that folder and extract that zip file. So once we have that extracted, now you can see that we just have the terraform.exe here, and this is already like it's ready to use, and you don't need to install anything here like I said previously. So all you gotta do is like configure your path to point to this. Now let me open up my PowerShell, and let's see if I have Terraform already set up, and let's see to what folder my Terraform is currently pointing to. We can say get command Terraform. Okay, so you can see that currently my Terraform path is being pointed to C, program files, Terraform, and Terraform.exe. So this is where I put my Terraform file. Now I can change that by saying that in my path variables I can go to my edit system environment variables, and I can say environment variables, and I can check for my path, and inside this you can see that this is my old Terraform path. Now I can edit this, and I can say this is my new Terraform path, and then click OK. In your case, there wouldn't be an entry here, so all you would do is basically select the new and give the folder path wherever your terraform.exe is present, and you'll just hit OK and then OK. So once you're done with that, now we have to restart this PowerShell because it won't pick up the changes right away. We have to reopen the PowerShell, and once we reopen, now if you do get command terraform, it should actually show us the new path, which is our documents terraform, which is whatever the path that we have here. So now the terraform is basically set up in our Windows system. Now let's just do a test command of like terraform version. So yeah, so you got back the Terraform version, which means like your Terraform is properly set up. So that's pretty much it for this lesson, and I hope you liked it. And if you have any questions, you can always get to me like by messaging in the channel or like personal messaging through the course. And I'll get back to your questions. So that's it for this lesson, and I will see you in the next ones. Thanks for watching. Hello and welcome back to #learning_courses, and today in this lesson we are going to see how to do AWS CLI setup. Now there are a couple of things. So first thing that you're going to do is basically download the AWS CLI from Amazon site, and you're going to install that program. And once you're done installing that program, you're going to go back to your AWS console. Like I said in my earlier videos, for this course you would need a AWS account so that you can create your user, you can download your access keys and secret access keys, and also you can follow along the lab so that you can create the resources which I am creating. Now so like I said, we are going to download the AWS CLI first, install it, then we're going to go back to AWS console, create a user if you don't have already. If you already have a user, then we can just go to that user, create the IAM credentials, the security access key and secret access key, and we are going to configure it as a profile using your AWS CLI. Because for using it, for giving Terraform the access to go ahead and create resources or delete resources or whatever you want to do, your Terraform needs to be authenticated with the AWS system. So creating a profile using CLI is one of the ways in doing it, and you can also give your access keys and secret access keys directly to your Terraform, which is not a good practice, but I'm still going to show you the different approaches that you can take to give access to your AWS system from your Terraform. So let's get started. So the first thing that we'll do is download the AWS CLI. So to do that, first just go to any web browser and just type download AWS CLI. I've already searched for it, I think from last time. So basically you can just go to any first link that you see. If you're using a Linux version, you can follow the instructions here. Now I'm going to show you how to install for a Windows. So I'm just going to select the one, install AWS CLI on Windows, and there is an MSI installer. If you want to choose another path, you can choose. I'm just going to download the installer, which is a lot more easy to work with. So I'm just going to download in this folder. Let me copy the path so that I can go there. So I'll download the CLI. Once the CLI is downloaded, what I'm going to do is open it. So I'm just waiting till the download completes. Yep, so it is downloaded here. So all you gotta do is like double click it and then select next, accept the license, hit next, and then install. Just give it a couple of minutes and it should be done. And okay, so the AWS CLI setup is complete. Now we can open up PowerShell or command prompt, whatever you prefer, and you can just do get command AWS. In Linux you can do which AWS. In PowerShell you can do get command AWS, and you can see it is resolving to something, so we know AWS CLI is installed. You can do AWS help and it's going to show you a bunch of different options that you can use with this CLI. And let's not go deep into this because this is not the topic that we are going to discuss here, but let's move on to the next step. So the next step that we have is to go to AWS CLI, AWS console, and create a user. And if you already have a user, you're going to go ahead and create your access keys and secret access keys. Now I already have a user, so I'm just going to go ahead and create new access key and secret access key. In your case, if you don't, it's always best practice to create a user and use it instead of using a root account. So I would suggest you to use a IAM user instead of the root account. So I already have the user, so I'm just going to go to my IAM console here, search for it, and once you are here, all you got to do is go to your users, search for your user, and inside that user you're going to go to the security credentials tab. Now inside this tab you should see a part here. Now I already have a access key and secret access key created. In your case, you wouldn't see anything if you are new to this. If you already have access key and secret access key, you can completely skip this step and use the ones which you have already. And even though I have it here, I'm just going to create a new one for this lesson's purpose, so that I can go ahead and delete after this lesson, and you guys can, even though if it is visible, you'll technically have no access. So let me just copy these into I'll copy it in a notepad just for now, because one thing to remember is, like, you can only see the secret access key once, and you have to copy it or download the CSV file here, and you can always get the access key from logging into your IAM console, and it should be visible. But secret access key, make sure no one gets hold of it, because they can technically do anything that your user has access to. So just be careful with it. Do not share it with anyone, and save it in a secure place. Alright, so the next thing that we are going to do is, now that we have this, the next thing that you have to make sure is, like, you have appropriate permissions. Now for this examples that I'm going to choose, I just gave my user the administrator access, just so that I can do anything with that I want with that access keys. Now if you are touching a few resources which you don't have permission to, if you want to experiment it with, just give access to yourself temporarily, and once you're done with the lessons, you can just get rid of it. Alright, so now that we have our AWS access keys and secret access keys, now let's plug them into our AWS CLI and create a profile. So to do that, the first thing that you're going to do is AWS profile, and you have to give that profile a name so that you can use that profile name in your Terraform scripts. So I'm just going to say AWS profile, you have to do -- profile, and you have to give it a name. So I'm just going to say Esrathan Terraform course. All right, and once I go into this, oh, my bad. So you have to do AWS configure -- profile, and Esrathan Terraform course is my profile name. You can give it whatever you want. So once you do that, it's going to ask you for the access key, and just key in the access key that you have created earlier, and the secret access key goes in here. Okay, now you can choose the default region. I'm going to for this course, I'm going to use EU West 1. You can choose whatever the region code that you would like to use. It's completely up to you. It's just setting a default region, meaning if you don't specify a region in your AWS command, you're going to end up using this particular region. So it really doesn't matter if you're specifying it anyways, but it's always handy when you have the default region set so that you don't have to supply it every time you run a specific AWS command. Alright, so I'm going to choose the EU West 1 here, and once it is done, you can choose the default output format, whatever the default is, and we are pretty much done. So let's go ahead and see or test like what exactly I mean if this particular profile configuration worked or not, and do the AWS help again. I think everything should be fixed. Yes. So now let's try to run IAM. I just want to see if my configuration worked or not. So I'm trying to retrieve the users from here. So retrieve users is like I want to use list users. Yeah, I can choose list users. So I can come out of this command, clear AWS IAM list users. Oh, I have to supply the profile, right? We have created a profile for it. So profile s ratan dash Terraform course, and like I said, you can see all the users that are there in my account, and this confirms that we have our AWS CLI set up properly. Okay, so that's it for this lesson. It's been a really long lesson, and we have successfully installed our AWS CLI. We have created our AWS IAM user. We have created our access key, secret access keys, and then we have configured in our AWS CLI as a profile with a profile name set, and then we have tested that our setup works. So that's pretty much it for this lesson, and I will see you in the next lessons. Thank you so much for watching. Hello and welcome back. So this is another lesson from #learning_courses, and in this lesson we are going to give a quick introduction to what we are going to cover in this particular section of Terraform Basics, and we are going to cover the first part of this Terraform Basics course. So let me just walk you through the different lessons that we are going to cover in this particular section. So we are going to start off by creating our first Terraform file, and we are going to initialize our Terraform file, and I'm just going to show you what is the extension and what are the files that it creates. And once we are done with that, we are going to talk about the state file and its importance. Basically, state file is something which gets created when you run your stuff. It keeps track of the resources that you've created. In this third lesson, we are going to cover like how are we going to give access to our AWS system, like how do we supply credentials to our Terraform file, and what are the different ways to do it. And the next thing that we are going to cover is the most important one, which is the Terraform variables. Now you're going to play around a lot of you're going to use the variables a lot in your infrastructure building, because it's one of the core components that you need to learn in Terraform. And the second thing is the next thing would be Terraform input variables, like how are you going to give input to your particular Terraform script from external command line. And the next important thing is like how are you going to output a specific variable if you have created something, if you have created a resource, how are you going to output a specific value so that you can use in some other case, or like if you want to view it as an output in your console itself. So these are the pretty much basics that we are going to cover in this particular section, and I'm just going to quickly stop this lesson, and I'll start a new lesson just in a bit, and then we will cover the first Terraform file there. So that's it for this lesson. Thank you for watching, and I hope you enjoy this particular part of this course. Hello and welcome back to another lesson in hashtag learning courses. And in this lesson, we are going to go ahead and create our first Terraform file. And let's get started. So first thing, what you have to do is you have to create a folder or a directory, depending on which operating system you're choosing. I'm in my course folder, and I'm going to just create a new folder saying first Terraform file, and inside this folder I'm going to create a new file. So the extension that you're going to use is .tf. So I'm going to create a new file which is going to be so I can just call it helloworld.tf. Now Hello World really doesn't make any sense in this particular piece of example, but it is a way of learning anything new in computer world. So I'm just going to use Hello World as the name. So I'm using helloworld.tf as my Terraform file. So inside, once you have this, all you have to do is open up your command prompt or PowerShell, and inside this, whenever you create a new Terraform file or you want to run anything, you have to initialize this particular Terraform file. To do that, you have the command of Terraform init. So this is the first thing that you have to do whenever you are creating a Terraform file. So once you do a init, you can see that Terraform has successfully initialized. So basically what this does is, let's say right now you don't have anything in your Terraform supplied, but if you have anything, let's say in the next lessons we'll be doing this anyway. So what we are going to do is we are going to tell okay, I'm going to use AWS as my provider, and I'm going to include some module, or I'm going to include this particular file or that particular file, whatever it is. So in order for Terraform to get that information saying that okay, I'm going to use this particular info or that particular info before I run anything, this initialization step will go ahead and figure out those details, and it will kind of download the dependencies or add the dependencies that this particular Terraform file needs. Now in our case, this is a very blank Terraform file and it doesn't have any information in there, so that's why it's just saying okay, Terraform has successfully initialized, and it doesn't have anything in there. So this is our basically blank Terraform file, and we have initialized it. Now there are some of the important commands that you're going to run in this particular course are Terraform plan. Now Terraform plan is something like a dry run of your script, saying that when you run this Terraform plan, it's going to actually check what all it is going to create, and it's going to list out the things that it will create, saying that okay, let's say you have listed out 10 resources that you want to create in your Terraform file, and you run Terraform plan. It is going to show you by verifying with the console, AWS console, or whichever cloud provider that you're using, and it will tell us okay, I'm going to create so and so resource, and I'm going to delete so and so resource, and I'm going to update so and so resource. So those are the kind of dry run information that it's going to provide, and it is always a best practice to run Terraform plan before you set anything, before you apply those changes, because you have to know what changes you are making, and you should be sure that if before you delete something or before you update something, so that you don't mess up the current state of your infrastructure. So that is what Terraform plan is going to help you with. So it is Terraform plan. So right now you can see that there is no infrastructure change, and infrastructure is up to date, and there is no changes that are going to get applied. The second thing is Terraform apply. Now when you do Terraform apply, all it is going to do is it's going to check, is there anything to apply. It's going to again do a plan thing, and then it's going to list you all the resources that it is going to touch, whether it's going to create, or whether it's going to delete, or whether it's going to update stuff. So you can see Terraform apply, there is nothing in this file again, so that's why there's nothing you will see here. And the third important command is Terraform destroy. Now, Terraform destroy is a really scary command because it is going to tear down the infrastructure that you have specified in this Terraform file. So it is like basically deleting everything that you have created using this particular Terraform file. So before running this, you have to be always careful about running this command, as it is really scary to take down the entire infrastructure. So whenever you run this command, Terraform is going to ask you for a confirmation. It is also going to ask you for Terraform apply confirmation. Right now we don't have any resources, that's why I didn't ask for apply, but for destroy it is always going to ask you for a confirmation whether you really want to run this command or not. So I'm going to say yes, and it is going to destroy whatever it is there. So really these are the most important commands that you're going to work with initially, and in the advanced lesson I'm going to show you more commands, but for now you have to just remember 3 commands, which is Terraform plan. I'm sorry, you have to remember 4 commands, which is Terraform init, Terraform plant, Terraform apply, and Terraform destroy. So these are the only 4 commands that you need to by heart, and that's pretty much it for your first Terraform file. And in the next lesson, let's go ahead and talk about Terraform Statefiles and Terraform basically Terraform state file and what is it and like why is it so important. All right, so that's it for this lesson, and I will see you in the next one. Thank you for watching. Hello and welcome back to another lesson in #learning courses. So in this lesson we are going to continue from where we've left off in the previous lesson. So in the previous lesson, to give you a quick recap, we have created our test first Terraform file, which is helloworld.tf, and then we learned a few commands, which is Terraform init, Terraform plan, Terraform apply, and Terraform destroy. Now once you have written something in your Terraform file, and you have run something like Terraform plan, Terraform apply, you are going to create some resources, right? Like if you, let's say if you have created an EC2 instance, or you have created a load balancer, you have created you have uploaded an S3 file, something like that. When you do something like that, there should be somewhere Terraform should record that information somewhere and keep it, right? It should keep track of what resource it created and like what are the IDs that got written from AWS and like those kind of information. So all those information are stored in a Terraform state file, which has an extension of .tf state. Now this tf state is really important because whenever you run the Terraform plan, basically Terraform uses this Terraform state file, and it basically compares your current state with the Terraform that you have currently specified in the .tf file. Meaning, let's say you have created an EC2 instance early, and you have run that as a Terraform plan and Terraform apply. Now what happened is you have created that resource in the AWS system, like you have a new EC2 instance running there. Now your Terraform state file will have that information saying that, okay, for this particular Terraform folder, we have created a EC2 instance and here are the properties. Now once you have that information in there, you go in your Terraform.tf file and you add a new resource saying that, okay, I also want a load balancer. Now technically when you're running, you should go and create an EC2 instance as well as a load balancer, right? But you don't want that to happen. You want the Terraform to go ahead and check, I already had EC2 instance, now I need a load balancer. So what Terraform does is, first it checks the state file and it verifies if your Terraform state file is in sync with what your Terraform file is. You'll have a mismatch there saying that, okay, I just had an EC2 instance, now I also have a load balancer. So I have to create a load balancer. So in your plan statement, it's going to tell you, oh, you already have a EC2 instance running. It also verifies if that EC2 instance is still running or not. If not, it will try to create one. Now that your EC2 instance is already running, you need a new load balancer. It's going to say, I want to create one resource, I want to modify no resources, I want to destroy no resources. That is 1 create, 0 destroy, 0 modify. So that's how you kind of create new resources and keep track of old resources that you have already created. So that is why .tf file, .tf state file, which is the state file, is really important, and it is going to keep track of all the resources that you have created. So there are different ways to manage this .tf state file. One is like either having it checked into your version controlling, or you can have a remote state file, like whenever you run something, your state file gets updated in S3 or wherever the remote destination that you have chosen. Now those are some of the advanced topics. We'll come to it at a point once we are like very much comfortable with Terraform, but let's focus on like Terraform state file. So whenever you apply something, your .tf state file is created, and now in the previous example, when we ran the bunch of commands, you can see here that there are few files that are created. One is tfstate and tfstate.backup. Now this tfstate.backup is something like you have run, you had a first run, and then you run a second time, you run a third time. It's going to like have the most current information in .tf file, and all the states that it had earlier, it will save it in the .tf backup file. So this is not that much of an importance. Really, all you need to care about is .tf state file. So in this file, this is just going to be a JSON file, which has like, okay, this is my version 3 because I ran it 3 times, right? And then I have my Terraform version, which is telling like this is the version of Terraform that I'm running, and currently you don't have any output or your modules or your resources or dependencies, right? So all this information gets populated once you have some resources that are created in here. So that's why Terraform TF state file is really important, and in the next lessons you're going to see, when you create new resources, how this Terraform state file is going to get populated. All right, so that's it for this lesson, and I will see you in the next lesson. We are going to go ahead and configure our AWS permissions in your Terraform file so that you can start creating new resources. So I'll see you in the next one. Thank you. Hello and welcome back to another lesson with hashtag learning courses. And in this lesson, we are going to cover different ways to give access to Terraform to go ahead and access the AWS resources using your credentials. So let's get started. So the first thing that we are going to do is like we'll go back to our first Helloworld .tf file that we have created in our previous lesson, and let me just clarify one thing. If you were having any questions in your previous example, and if you're like kind of overwhelmed, don't worry at all about it, because we are going to do so many examples that you'll clearly understand by what I mean with the Terraform state files and like what are the different commands. You'll just get used to it once you see like a sufficient number of examples. All right, so let's get back to this. So how are you going to give access to your AWS console to your Terraform file? So first you need to specify that, okay, I'm going to use AWS as my provider, right? I mean, like I mentioned in the introduction classes that Terraform is a multi-cloud compatible infrastructure as a code tool, meaning like you can create resources or you can manage infrastructure in many clouds like it could be Azure, it could be AWS, or it could be any other provider which Terraform supports. So the first thing that you need to do is basically tell Terraform that, okay, I am going to be using the AWS as my provider. So how do we specify that? Let's check it out. So first thing you need to do is like open up your helloworld.tf. I am going to open it up with my Sublime. Let me bring up my Sublime, and I'm going to open up this particular file here. Alright, so in my Terraform file, what we need to do is basically we need to select our provider, right? So the provider, you're going to specify it by saying, okay, I need a provider, and you need to open this curly brace and close curly brace, and you need to specify here AWS, because AWS is my provider, right? So provider name, which in quotes, and then you're just going to save it here. Now this provider would take inputs like access key, secret access key, or a profile name or region, whatever the properties that you supplied when you are setting up your AWS profile in your CLI lesson. Those are some of the properties that this is going to take. But for now, what we are going to do is we are just going to save this as it is, just saying that, okay, I'm going to use AWS provider, and let's see what happens if we run Terraform. If we run the Terraform plant, Terraform init, because we are adding a new provider, we have to reinitialize it because it needs to add the provider details. Let's see what it's going to do. So we are going to do Terraform init, right? So first thing it did was it checked, okay, this is a provider that he's going to use, and what it is saying is it's downloading the plugins for that provider. So this plugin will have all the information of like how the AWS is going to interact with this particular Terraform file. It is going to use this plugin to kind of create your resources, like issue commands to your AWS system. Alright, so you can see that we have downloaded our provider plugin, which is AWS, and it is of version 1.39. Now Terraform has a active contributors in GitHub, and like they are solving issues and bugs every single day, and they keep on updating the versions here, which is a good thing, because the more the contributors, the more the issues get solved, right? So coming back to this, okay, so now we have the AWS provider, what do you call this, plugin is installed for this particular Terraform file. Now if you go back to your folder, you can see there is .terraform folder created, and within this you can see that, okay, I am using this particular Terraform provider, and it is going to use this particular executable to execute the commands. Now coming back to here, now let's open up the Terraform file, Terraform website itself, and I want to just quickly show you how the documentation looks like, and how you can help yourself by going into the guides or the documentations to figure out stuff. Now we have created the provider block, and we want to see what properties this particular provider will be able to take. Now if you want to check that, you have to go here and then go to the docs, and you can see providers. And like I said, Terraform is a multi-cloud thing. You can see like there are so many providers that Terraform supports. Now the one which we are interested in is basically AWS. Now if you go here, you can see that these are the properties that it is going to take in, and this is an example of it. So provider AWS, and it's going to take access key, secret access key, region, and you can create resources like AWS instance, web. We're going to come back to this particular part later, but all we are interested in is seeing how we can supply our credentials. Like I said, there's like multiple ways to supply. One way is to supply the credentials directly, saying that okay, this is the access key, this is a secret access key. The other way is saying that okay, I have my profile in my shared credentials file. I'm going to say okay, this is my credentials file, and this is the profile that I want to use. Now you can, if you're using just the default credential file and you have a profile set in there, you don't have to specify shared credential file. Now in our example, we have used the default credential file, so we don't have to specify the path to that, and you can directly use the profile. So that is how you are going to basically use the shared credential file or the profile that you've created. And the other way is to use the assume role, like if you are basically using STS, which is session, it's a way to issue temporary credentials to a user, and those credentials usually expire after a certain period of time. In those circumstances, you're going to specify the session name and session the role, ARN, etc. For this course, we are not going to use that particular way of accessing the AWS credentials. So let's go and try two ways. One is to run this with the access key and secret access key, and the other way is to use the shared credentials file. So let's go back to our Sublime, and then we'll just take we're going to say region. We are going to say region equal to US EU West 1, and we are going to say access key equal to, I think I have it open, access key is this guy, and secret key is this guy. Now I can go and do Terraform plan. You can see that it has refreshed and there is no infrastructure change because you haven't created anything yet. But it gave us it gave us no errors. That means that we have configured it properly. So this is one way of supplying the credentials, and the other way is, I can just comment this out. Not sure why the comment key is not working. Anyway, so we can just get rid of these two, and we can say profile equal to, let me quickly double check. So you can see, yeah, profile equal to, what are the profiles? So my profile is S-dash Terraform course. So this is my profile name, and if I just go back and run Terraform plan, again it's going to run it, and then it's not throwing any errors, which means it has been configured properly. So now you have two options, right? You have either specifying the access key, secret access key, and the other way is to specify profile. Now which one do you need to choose? The answer is simple: always choose the profile, because it is always a good practice not to check in your access key and secret access key. And also when you're working as a team, there are multiple people who are actually modifying stuff to your infrastructure, right? In that case, you want to be able to track like who ran these particular changes or who added this particular resources. And if you have a shared credentials and say, okay, I'm just going to check in credentials for Terraform and I'm just going to allow everyone in my team, then if someone deletes something or if someone does anything bad to your infrastructure, how are you going to figure out who is the person that ran that particular script, right? So in order to do that, you need your profiles, and every developer can have his own local profile set, and when he ran some stuff, I mean when he creates something, and AWS will record as saying that okay, so and so person has created so and so resource. So that's how you can keep track of who created the resources, as well as you can keep track of I mean you can keep your access keys and secret access key in a secure place without sharing them or exposing them in your version controlling. So I hope you understood like how to create a provider in Terraform and supply your credentials to it so that you can go ahead and create the resources. So that's it for this lesson, and I am going to see you in the next one. Thank you for watching. Hello and welcome back to another lesson in #learning courses, and in this lesson we are going to look at Terraform variables. Now, as you know, variables kind of play a very important role in any programming language, and similarly in Terraform we do have support for variables, and let's look at the different types of variables that are supported here. Now, the types of variables that are supported here are basically strings, maps, lists, and booleans. Now, these are like common types that you find in any programming languages, and let's look at the syntax of how to use these variables and like how to kind of use how to declare these variables and also how to consume these variables. So let's look at the first one, which is the strings. Now, strings is kind of a commonly used variable because you can declare stuff like your name of the specific resource, or name of a VPC, or ID of a VPC, or anything that relates to your infrastructure. You can declare it as a string, and then you can consume it as a variable within any Terraform blocks that you would like to create or utilize. So let's go ahead and write some code and test it out to see whether that works out or not. So I'm going to open up my same file which was used earlier in the earlier example, which is my helloworld.tf. Now within this helloworld.tf, what I'm going to do is I'm going to type in the code that we see on the screen. So let's declare some strings. Now I'm going to comment saying that this is a string variable. Okay, now to declare a variable, it is really simple. All you gotta say is like, I'm declaring a variable. It's variable and followed by a key. So key is like the name of the variable with which you would be referring within your Terraform script. Now I can say my first string, and you should open a curly brace, close curly brace, and inside that you have to declare the type. Now type is string. Now if you don't specify a type, and if you just specify the default value, it will automatically assume that it is a string if it is a string, and kind of self-evaluates to a string. But it is always a good practice to specify what type of variable it is. So we're gonna say type equal to string, and inside this we're going to say default equal to, and whatever the value that you want to give, saying that this is my first string. So that's how you declare a string. Now, how to consume a string. So let's talk about, I'm just going to put in the output variable here, my first output. I'm going to explain you when and why we need output variables in the next lesson, but for now just look at it as like, okay, this is how you're going to output. I'm going to explain why and when we'll be using the output variables, so just ignore it for this lesson. So I'm just going to say value equal to. Now here's the important part. So this is the reason why I'm using here. I'm showing you how to consume this particular variable within any block. So I'm just consuming it here in output so that I can show you the output that that string is consumed. So to use any variable, you need to open double quotes. Inside that you need to specify dollar open curly brace, close curly brace, and inside this you're going to say var dot first string. Now you're saying, okay, I want the value of variable of first string, so that's what you declared here. Now hit save. Now go back to your PowerShell, and inside your PowerShell, what you're going to do is you're going to again do Terraform plan. Okay, we haven't added anything to the infrastructure, so it's saying it's up to date, but let's just apply Terraform apply. Now once you apply, you should see the output variables getting printed. Now if you see here in my output variable, you should see my first output is equal to, this is my first string. So that's what you've declared here. So that's how you declare a string and consume it. Now there are certain cases where you will need multi-line strings to kind of input your variables into let's say user data scripts for EC2 or SSM commands, or it could be any use case. I mean, stuff like uploading a document to your S3 by customizing that string within the Terraform script. There can be any use case. So that's why they also support multi-line strings. So the way you declare multi-line strings would be, let me just copy this variable here, and you can say multi-line string, and inside this you're still going to be calling it as type of string, and instead of this open quotes, you're going to say EOH, and here you're going to say this is a multi-line string new line. I'm just making up things here, and you have to end it with EOH again. So it's starts with two left arrow brackets and then EOH, and then the content that you want to put into that string, and end it with again EOH. And let's output this variable and see. So I'm just going to copy this output variable and add it here. I'm going to say my multi-line output, and I'm going to say multi-line string. Right now, if I go back and do Terraform plan again, there should be no changes, and I'm just going to apply, and you should see that okay, my multi-line output, this is a multi-line string new line, so it's all printing out nicely. And we have now used strings, multi-line strings, and also we have outputted those variables. I mean, we have consumed those variables within the Terraform. So that's how you use the strings. Now let's go ahead and look at some other type of variable and see how it's going to be used. Now let's start with the maps. Now maps is typically used for key value pairs. Let's say if you have a variable that's holding multiple keys and multiple values, and you kind of need them all grouped together in a one variable, that's when you use the maps. The good example for this would be, let's say if you're familiar with AWS, then you should be familiar with regions and AMIs. Okay, so let's say you have a set of AMI that you've created in each different region, and you want a one Terraform to be used, and you want to specify different AMI when you're running in a different region, right? So in that case, what you can do is basically you can create a map variable, and you can say if I want US East, I want this specific AMI, and if I say US West, I want this specific AMI. So that's one of the use case that you can use maps for, and there are many other use cases. We are going to use it in the coming examples when we are actually working with the infrastructure. I'll be showing you many different examples how to use maps and like where it fits properly. So for this example, we are going to create the same code, and let's see how it's going to work out. Now here what I'm going to do is I'm going to say this is my maps example, and here we are going to say again variable, and we can say map example, and inside this we are going to say type equal to map. Now again, if you are declaring a map here and if you don't specify type equal to map, it's still going to read it as map if you have formatted it properly, but it is a best practice to declare the type of variable that you are declaring here. So here we're going to say default equal to, and here we have to open and close the curly brace, and inside that you can again say you can specify the key values. So I'm saying AMI1, EU West, AMI2, right? So this is how you have declared the AMIs, and I mean the map, and the way you are going to output is output map output, and here inside this we're going to say value equals, we're going to say, again we have to open open curly brace, close curly brace, and inside this we are going to say var dot map example, right? And here you have to refer to the specific key by opening and closing a square bracket, and inside that you have to specify it in double quotes saying US East or EU West, whatever the value that you want to use. Now if I save this and run my Terraform saying Terraform plan, again there's no infrastructure change, Terraform apply, now you should see my map output equal to AMI1, right? So that's the map output, and we got the output as AMI1. So that's how you use a map variable. Now if you want to use the other map, other key, you can just say EU West, and if you apply, you should see map output equal to AMI2, because now you're using the second key here. So that's how basically maps are used. And like I said, I'm going to show you many different applications of this map in the coming lessons, and that's it for this map. So now let's go ahead and see another variable type, which is our lists. Now lists are basically arrays, and there is no special introduction that's required for why and when to use arrays. There are many use cases where arrays are used. So let's go ahead and look at how to use the array. Now array or the list, whatever you call it. So this is arrays or lists, okay? And in this we are going to say variable let's call it my security group list. Now the way you can use list is basically you can say type equal to list again, and inside this you can say default equal to, you have to specify open square bracket, and within this you can say security group 1, security group 2, security group 3, so on and so forth. And you can use this as output. You can say security group output, and inside this you can say value equal to, again you have to open up open curly brace, close curly brace, and within this all you gotta say is my security group list of, you have to specify the index of a specific element if you want to choose a specific element from within the list. Now you can just say save it, clear this out, Terraform plan, Terraform plan. Oh yeah, my bad. So I have to do this var dot my security group, because I'm referring to a variable and I forgot to put var there. That's why it kind of complained. Let me clear the screen. So I'm going to run again Terraform plan, and no changes again, Terraform apply. Now if you see, you should have an output variable saying SG output equal to SG1. So that's what we are referring to SG1 here. Now in some cases you need to, like, you might need to apply all the security groups. Let's say if you have multiple security groups and you want to assign all those security groups to your EC2 instance that you're creating, in that case you can just say, okay, I want everything from this list. So how do you do that? So you just don't need to specify this particular index in the square brackets. You can just leave it like that and it should work. Now if you see, SG output is an array of SG1, SG2 and SG3. So that's how you basically use the lists, and that's how you're going to output them or consume them. So that's about it for the lists, and let's go ahead and take a look at the other variable type, which is booleans. Now booleans is also one of the most commonly used data type, and we're going to check it out how to use it. Now for boolean, you don't need to specify the type. It's going to figure it out based on value true or false. Now also there is two ways of declaring it. So you can say variable test bool, and you can say it as default equal to, you can declare it as a string, or you can declare it just like true. Now if you declare it as a string, it will also treat it as a bool when it is applied to a appropriate variable. Let's say you have a bool flag you have a bool variable expected in a Terraform block, and you're supplying a string of bool which is like true within a double quotes. It's going to still treat it as a bool. If you specify it without the strings, it's also going to treat it as a bool. So it really doesn't matter, but if you look up the documentation for Terraform, it's going to specify, saying that it's going to tell you that there's some version incompatibility, so you can choose either ways. I would prefer to just say true instead of having it in a double quote. So it's up to you whether to use it in a double quote or not. So I'm just going to say default equal to true, and if you output this, let's say output bool output, and again I'm going to say value equal to dollar open close, and inside this var dot test bool. Now if I output this, I will not get true or false in a string. I'll just get 0 or 1. So that's how bools are represented. And let's open up our PowerShell, clear out of it, and run the command again, terraform plan, and apply terraform apply. Now you should see your bool output is 1 because it's true. Now if I set it to false, save it and run terraform apply again, you should see my bool output equal to 0. So that's how the booleans are used in Terraform, and that's pretty much it about the variables. And I'm going to talk to you about more about these variables as and when they come up in the examples that we are doing. And that's pretty much it for this lesson, and it's been a really long lesson, and I really hope you got to learn all about the variables in Terraform, and I will see you in the next one. Thank you for watching. Hello and welcome back to another lesson in #learning courses, and in today's lesson we are going to learn about input and output variables in our Terraform course. So basically in the previous lessons we have seen how to use variables and what are the different types of variables that you can create in Terraform. Now in this lesson we are going to see how you can utilize the feature of inputting the variables to a Terraform script so that you can pass in some dynamic variables, and how you can utilize output to kind of see those variables. And also I'll talk about like where else you can use the output variables. So let's get started. So the first thing that we are going to do is like to see how we are going to take the input to a specific variable. So what I'm going to do is I'm going to open up my same Terraform file that we have used in the previous lesson. Now in this I'm going to say variable input, my input variable. The name really doesn't matter here. All it matters is what type we are going to use. So I'm going to say type equal to string. Now here what I'm just going to do is inside this I'm not going to specify a default value. I'm just going to leave it like this. Now what I'm going to do is I'm going to output this variable just like I did in the previous lessons. So my output variable, and inside this I'm just going to say value equals and I'm going to refer to the variable that I'm going to input from the console, I mean the PowerShell, and let's see how it outputs it. Now to reference to this, all I have to do is var dot my input variable, and that's pretty much it. Now if I run my Terraform using Terraform plan, invalid key value, yes, so this is not a variable, this should be output, right? So we are outputting that value, so it shouldn't be a variable. So let me clear this. I'm going to do Terraform plan. Now you see it's asking me to input the variable which is going to take in that value that I'm going to specify here and store it into that variable, and it is going to output back again because we have specified in the output variable to put that information out. So I'm going to say this is my test input and hit enter. And now when you do Terraform, oh no, so in Terraform plan it doesn't do anything because it's not actually outputting stuff, it's just a test plan. But if you do Terraform apply, it's gonna ask you for the same input again. So in this time it is going to output. So this is my test input. Now if you see, you should see my output variable equal to this is my test input. Now you might have observed one thing, that the output here is not in a specific order of what we have written in our script, because Terraform will not follow the order in which that you have specified here. It follows always the dependency model, wherein you can say a certain resource depends on a specific resource, then it will wait, then it will create the resource in the order of the dependencies. Let's say A is dependent on B and B is dependent on C, then it will create C first and then it will create B, then followed by A, because A is dependent on B and B is dependent on C. So that's how it follows the order, but it doesn't follow the same order that you have specified in the script. So always keep that in mind. So now you have seen the input variable, I mean taking an input, and also you have seen how to output this. Now another important thing about output is basically, let's say you are putting out some sensitive data, right? So let's say you're creating some secret keys or stuff like that, and you are outputting it, and you don't want it to be visible to the person who is executing those commands. Then in that case, what you can do is you can supply a parameter called sensitive equal to true, and when you do this, you'll not see the output, but you'll just see that this is a sensitive piece of information, and it will not show you that piece of information getting out in the console. So we can clear out from here, and we can say Terraform apply again, and this is my test input, and you should see that my output variable equal to sensitive, which means the output variable has that information, but it is not showing us here. But if you use the output variables when you're dealing with modules, I'll come to the modules part when we are dealing with that section. So basically you can the reason why you have output variables is, one, to show it to the user who is running, and two, if you want to share your variables across different modules when you are you reusing some of the Terraform components in other Terraform scripts. That's when you kind of use the output variables. So that's pretty much about the input and output variables. And if you need more info, you can always go to terraform.io website, and you can check out the docs about different types of inputs and outputs, and also the different types of variables that are supported there. So that's pretty much it for this lesson. If you have more questions, you can always ping me through the course, and I will be happy to respond to those questions. So that's it for this lesson, and I will see you in the next one. Thank you for watching. Hello and welcome back to another lesson in Hashtag Learning Courses, and in this lesson we are going to give you a quick introduction of what we are going to cover in this particular section. So in the previous section we have covered the basics of Terraform, like Terraform variables, inputs and outputs, and in this section we are going to cover the basic AWS components that you will be creating using the Terraform. Now here are some of the components that you'll be creating. So the first, we are going to start off by creating an S3 bucket, and we'll upload the files, and during this process we'll also see how to use Terraform destroy to actually delete the resources that you have created. Followed by, you'll create a new EC2 instance. We'll also look into how to create application load balancers and target groups, and we'll also see an example from CloudWatch, and we'll create an SNS topic in this particular section. You'll also experience like how to use variables in this, how to use inputs, and I'm going to cover all the basic stuff that I've taught in the previous section. We'll be using all those things in this particular section. So I'm really excited to start this particular section. Let's go ahead and start with the creating of S3 bucket, and I will see you in the next one. Thank you so much for watching. Hello and welcome back to another lesson in Hashtag Learning Courses, and in this lesson we are going to create an S3 bucket and upload a test file using the Terraform scripts. Now before getting started, I want to show you how to use Terraform documentation to kind of figure out like what resources do I need to choose, and like what input variables that I need to supply, and what are the required variables and what are the optional stuff that I can use to configure. So to get started, let's go to the website terraform.io. Now here we are basically trying to go ahead and create an S3 bucket. So let's go and see how to find that S3 bucket resource documentation. Now to find the documentation, all you have to do is go to the docs section here, and you need to choose the provider. Now like I said in the introductory lesson, saying that Terraform is supported by many different providers. You can find all those providers here. The one which we are interested in here is basically AWS. Now inside this AWS, there are two types of things. There are data sources, and there are resources. So we are not looking for the data sources here. Data sources is like when you create a specific resource, what type of output information that specific resource is going to provide. That is not what we are looking for. We are looking for the AWS resources itself. So I'm going to search for AWS S3. Now if you search for S3, this is a data resource. You can see here, so S3 resources. So this is what we are looking for, and we want to create the bucket. So click on that, and you should see that AWS S3 bucket is the resource name. And so you'll specify resource, whatever the resource name is, AWS S3 bucket, and whatever the reference name that you want to give within your Terraform script, so that you can refer to it. So this is like a variable name, so you can specify whatever you want here. And inside that, it is expecting a bucket. Bucket is the bucket name that you want to create, and what is the ACL, which is like who wants to access that. By default it would be private, and you can specify some of the tags here. Now if you want to create a static website hosting. These are the parameters that it is expecting, and if you want to utilize cars to that, you can specify cars rules. And these are all the examples that the documentation is showing. But if you want to see what are all the supported arguments, you can scroll more down and you can see argument reference. You can see what are the optionals values, what are the required values, and all those things. You can see which region it is asking you to create, and those are all the different properties that you can specify. Now for our example, we are just going to go ahead and create an S3 bucket in Ireland region. So let's see how to do it. So I'm just going to minimize this. I'm opening my PowerShell. In my course folder, what I'll do is I'll create a new Terraform folder, which is going to be S3 bucket, right? Inside that S3 bucket, all I have to do is create a new Terraform file, which I'm going to say main.tf. Alright, so my main.tf is created. Now I'm going to edit it with my where is my Sublime? Let me open Sublime first. Okay, this is our previous file. Let's open the file S3 bucket. Okay, so my main.tf is opened, and I want to copy the same stuff that we have used in the previous lesson. That is we have to specify our provider. So I'm going to use the same provider here. We have specified the region, and let's go ahead and create our first S3 bucket using this particular Terraform file. So to do that, we can see that we need resource AWS S3 bucket, right? We can just replicate what is here. We can say resource. We have to give what type of resource you want to create, and you have to give it a name. So I'll say my bucket, and open close. Inside this, you're saying bucket name equal to my bucket. Underscores are not supported, so you'd say tf course, and you will say today's date 10/11/18, and this is just to make sure that we are not creating something which is already existent, because S3 doesn't allow a duplicate name. So I'm just making up some random name. For you it might be a meaningful name, so I'm just leaving it like that. We just need a private one. We can also specify the region. We've already specified the region here, EU West 1. We don't need to specify a region, but still, if you want, you can omit this part and you can specify the region here individually to different resources. So I'm going to specify a region here to say EU West 1, and I'll just give it a name. Inside the tags, you can say name equal to what is the tag name. I'll just call it name, and I'll say oh no, so inside tags you can say tag name and tag value. So I can say name, I can just call it, let's call it environment dev, right? I just want to give one tag for now, and let's see if there's anything interesting that we can supply more here. So bucket prefix, ACL policy tags, force destroy, website, course rule, versioning, logging. I think that's pretty much it. I don't want to overcomplicate this particular part. I would just go with the basic S3 bucket creation. So now that we have this, we can go ahead and create the bucket. So the way we'll create is basically go to the folder S3 bucket, and inside this we'll do Terraform plan. Okay, something went wrong. So what did I say? Whenever you're creating a new Terraform file, always remember to initialize the file. So I'm clearing this and doing Terraform init, Now once you do initialize, it will download the required AWS SDK, and once you have that AWS SDK and plugins ready, you are good to go and run the Terraform plan. So let's wait until the plugins downloaded for us. Alright, so the Terraform has been initialized, and you can see that it has completed the downloading of the all the required plugins, which is our AWS plugin. Now I'm going to clear this part and run the other command, Terraform plan. Now you should see that we are creating one resource, which is our AWS S3 bucket, and it is going to choose the ACL as private. We're going to give the name as my bucket -terraform course today's date, and we have supplied the region, and that's pretty much it. Now to actually create, basically, like I said, plan is just going to tell us what we are going to create, but when you run the command terraform apply, that's actually when you create the specific resource. Now let me clear it from here. Let's run terraform apply, and once you apply it, you should see that it will ask you for a confirmation that yes, you want to create. So it will only take yes as the accepted value. So let me supply yes and hit enter, and you should see that it is creating my AWS S3 bucket. And once that gets created, I'll open up the AWS console to verify that our bucket has been created. So it's going to take a bit of time. Okay, now you can see that it has completed creating that resource. Apply complete. One resource has been added, and now if you're curious, you can go to your S3 bucket folder here, and you can see in the terraform.tf state, you can see that there is one resource which has been added, and this is the information or the metadata that is associated with that particular resource. Now when you do changes to this particular resource in the Terraform file, and when you run Terraform plan, the Terraform script will actually find the differential between the metadata that is in terraform.tf state and the actual infrastructure itself, and does a compare, and if it finds any difference, then it will prompt you saying that okay, this is the stuff that you need to create, or that is being updated, or that is being destroyed. So that's how it's going to work. So let's go back to our AWS console and go to our S3 section and see if our bucket has been created or not. So if you go to AWS console, I'm going to go to the S3 here, and inside S3 now I'll have to search for the bucket, which is, I have so many buckets here. You can see what did we name here. So what did we name here? My bucket tf, right? So let's look for the my. Okay, so now you can see here it has been my bucket tf course. If you go here, my bucket tf course, you can see that it is not public because we have set the access control list as private. That's why it's not public, and your bucket is created and ready. Okay, so now you have your bucket ready. Now let's go ahead and see how you can upload a test file to this particular S3 bucket. So in this, what I'm going to do is now again go back to my Terraform documentation, and I'm going to search for S3. Maybe I'll just go all the way down, and here we want to upload an object to it. So I'm going to use AWS S3 bucket object, and you can see the argument reference when you scroll all the way down. I'm just going to use this particular example. I'm saying I need a resource which is AWS S3 bucket object, and I'm just going to give it a reference name, and I'm going to supply the bucket name, and we are using the key. We are supplying the key name that we want to use, and we are going to give a path to this particular source file, and we can create the e tag, which will check for the, e tag will basically do a compute on your data of your file, and then it's going to come up with a e tag, and whenever you have some changes in that, your e tag will be different, and that's how it's going to compare and see whether a new resource has to be uploaded or it just has to ignore whenever you are running the Terraform. So let's go ahead and check it out. So I'm just going to copy this entire block here and I'm going to paste it here. Now what are the things that you need? We need to give it a name, right? So I'm saying my first object and the bucket name. So here's an interesting application that we have learned in the previous introduction. So the way you're going to reference, we already have created the bucket here, right? And we don't want to hardcode our bucket name here. Instead, what I'm going to show you is like we're going to reference this particular bucket's name from this particular resource. So I'm going to say dollar open close flower brackets. Inside that I'm going to say AWS underscore S3 underscore bucket dot name. Now how do I know that it is going to support this name? We can go to the data sources now and we can search for AWS S3 bucket. Now if I open this in new tab, you should see what are the data that it is going to output. Okay, so it is going to output the name of the bucket as ID. So I'm wrong here. We don't need to, we should not supply name, we should supply the ID here. And the object key, I want to give it as like test file .txt and path to the file. Now we have to create a file, right? So to create a file, I'm going back to my folder S3 bucket, and you can say inside this course I am going to create a new test files, and inside this I'll create a new text document which is going to be sample object.text, and inside that I'll just, this is test. In your case it could be a real object. So now how do I reference to this particular file, right? So all we have to do is say we want to go up one folder because we were in the S3 bucket folder. So we have come to one up and we are going to go to the test files. So inside this we have test files, and inside test files we have sample object.txt. So we can say sample object.txt. Now we are going to supply the same thing inside this, and now let's run this thing and see if it actually uploads this particular object into S3 or not. So to do that, I'm just going back to my we're going back to our Terraform we're going back to our PowerShell, and inside this I'm going to clear off this and say Terraform plan. Now if we have done everything right, we should not see a S3 bucket resource being created. We should just see a S3 object being uploaded. Now if I ID must be 3 parts, type, name, attribute. Okay, what did we do wrong here? So I think we have to give var dot okay, it's not a var, so let me go back to this. Oh, actually it is data, right? So it's going to be data.aws s3. Now if we do Terraform plan, okay, I know what we are doing wrong here. So it's actually AWS S3, we didn't specify which S3 bucket, right? So we have to reference our bucket reference name that we have created here, which is my bucket. So we have to do AWS S3 bucket dot my bucket dot id. Now if I go and run Terraform plant, it should work. Alright, so it is refreshing the state and it is basically checking, do we need to create a new bucket or not? And if you see, it's not asking us to create a new bucket, it is just saying that, okay, we are uploading our first object here, and there's nothing to change and nothing to destroy. So now we'll clear this, we'll do Terraform apply. It's again going to refresh the state and verify if everything's okay, and then it is going to ask us for a confirmation. Okay, so it is asking for the confirmation, so I'm going to say yes because I want to create that S3 object, and hit enter. And once you do that, you can see that your resources is applied and you have 1 added, 0 changed, and 0 destroyed. Now if you go back to your S3 console and do a quick refresh, you should see a new object, which is test file, that you have uploaded using the Terraform. Now that's how you're going to upload. Now next thing that we are going to do is like how to modify a specific resource. Now to modify a specific resource, like I said, in the when we are creating it, it's going to check the e tag, right? Now if we go ahead and say in my test file, if I say this is a test file, now I have modified the text, right? Now the Terraform should detect that there is a change in my file and there is a change that needs to be applied to the infrastructure. Let's see if that picks it up or not. So I didn't change anything in my Terraform, it's all the same. All I did was like change the sample object.txt file. Now I'm going to do a Terraform plan again. Now you should see that there is a difference and it needs to create a new object because the old object is different from the new object, because the new e tag value is different from the old object. So you can see that the e tag has been changed, so it will have to update that file. So you have to do Terraform apply. You can see that there is 1 thing to change instead of 0 to change, 1 to add. So we are changing just 1 file there, and let's apply. Once it's applied, we'll just hit yes, and you can see that the resource has been applied, and it is. Now if you go here, you should see the last modified date being changed. Last modified was 1039. Now if I refresh, you should see 1041. So it's the latest file that we have uploaded. The changed version, without changing anything in the Terraform file, it automatically picked up the changes in the test file and it uploaded a new object. Okay, so now we have created our S3 bucket, we have created our new object. Now let's go ahead and tear down our infrastructure. Now tear down meaning like we are going to destroy all that resources that we have created. Now you should be very careful when you're running this command because this is going to take down everything. So let's clear out from here and let's try Terraform destroy. When you do Terraform destroy, it's refreshing the state and it's going to give you a list of all the resources that it's destroying. So if you see, it is destroying 2 resources, which is your S3 bucket and your object. Now if you supply yes, it's going to go ahead and tear down those things. Now yes. Okay, so destroy complete, 2 resources were destroyed. Now if you go back to your AWS console and if you refresh, it should say that there is no bucket, data not found, because the bucket we have deleted. And here you should see that there is no, if you refresh this, it should go away. Okay, this is an old bucket. There's no my bucket here, which means that we have successfully deleted the resource. And that's pretty much it. This is a pretty long lesson and I really hope you have enjoyed. working with the Terraform to create the AWS resource, to modify it, update it, and actually delete the files. So that's pretty much it for this lesson, and I'll see you in the next one. And if you have any questions, you can always ping me in the course, and I will be happy to respond to all your questions. Thank you for watching. Hello and welcome back to another lesson in #learning courses, and in today's lesson we are going to see how to launch an EC2 instance using the Terraform scripts. Now in this lesson, to launch a new EC2 instance, we have two requirements. One is to create an EC2 key pair, and to create a security group. Now these two resources can be created using Terraform, or it can also be created with the console. I'm just going to walk you through how these can be created using the Terraform, and then I'm going to use the console to the AWS console to create these requirements, and then we'll see how to launch the EC2 instance using the Terraform. So let's get started. So the first thing that I'm going to show you is like how to create the key pair using the Terraform. So to do that, first let's go to the Terraform documentation, which is going to be in the terraform.io website, and to go to the documentation, go to the docs section, go to the providers, go to the AWS, and the one that you are looking for is AWS_key_pair. Now if you select this, now you should see that you can for you to create the AWS key pair using the the Terraform scripts, you need to create a public key beforehand, and you have to supply that to AWS to register your key pair. So to do that, what you need to do is you need to have there are different ways you can create, and these formats that are supported are basically OpenSSH public key format and base64 encoded DER format, and SSH public key format specified in RFC 4716. Now one way you can create is like if you are using Windows, you can use PuttyGen. And inside PuttyGen, what you need to do is you just have to say generate, and you have to just rotate your mouse here to create some randomness, and that's going to create the public key. The public key, and you just have to click save public key, and you can just give it a extension of .ppk and copy the text that is here, and use this block of Terraform code, which is resource AWS key pair, and give the name that you want to give, and give it a name which you want the AWS to recognize, and just apply the generated public key here, and then all you have to do is basically Terraform plan and apply, and that should be it. And to create this using the console, I'm just going to walk you through that in a minute. And for creating the security groups, all you can do is go to AWS security group, and inside security group you just have to say no, this is the data source, I'm sorry. So inside you have to create a resource AWS security group. You know what, let's go ahead and do this using the Terraform, so that you will be having one more example to play around with. So firstly, I'll go to the AWS console and create my key pair. To do that, you have to go to the AWS console, go to EC2 section, and inside this you have to go to the key pair section. If you see inside the network and security, you should see the key pairs. Now select key pairs and create key pair, and just give it a name. Let's call it Terraform course. All right, that sounds pretty good. And inside Terraform course, we can say Terraform course.pem. Yeah, we can save it here. You will need to have this handy, because you need that to basically connect to a EC2 instance. So that's why you need this particular key before you launch an EC2 instance. So okay, so now our first requirement is done. The second thing that we are going to do is go back to our Terraform course folder, we open up the course folder, and inside that we're going to start off with our EC2 Terraform folder. So we have to go and create a new folder, call it EC2 Terraform, and inside this we are going to create a Terraform file which is going to be main.tf. Alright, yes, we want to change the extension to .tf, which is our Terraform file. Now, as usual, I'm going to open this file inside my Sublime, and we have to do some basic stuff. So I'm going to go back to our S3 bucket, open this guy up, and copy the block of code of provider. Close this, paste, because we need the provider here and the Terraform course, our profile name for the AWS access. Okay, so like I said, we are going to create our security group using our Terraform. So let's get started. So first thing that I'll put in here is go back to my AWS documentation for Terraform and search for AWS security groups. Okay, so we are already in here, and in this let's copy this block. Alright, so now if you are completely unfamiliar with security groups in AWS, basically security groups are like a firewall that you can place in front of your instance, and you can control who can access like to the instance, who can have inbound access and what outbound access that particular EC2 instance has, and all that network traffic gets filtered using this security groups. So it is really essential for any EC2 instance to have a very good security group rules placed, so that you don't have any unauthorized access coming to your EC2 instances. Okay, so let's go ahead and create one. So let's create the security group name as Terraform EC2 security group. I just call SG as a security group, and I'll usually place the resource name same as the actual the resource that we are creating, and let's give this description as Terraform course security group for EC2 instance. I'm just making that up. And one thing you need is basically the VPC ID. Now for this lesson, what I'm going to do is I'm going to use a default VPC. Now the default VPC you can find out by going to your VPC in AWS console, and inside that you should see a default VPC. So if you go to your VPCs, you should probably see a default VPC. Now this is your default VPC, and you can copy this VPC ID here, and you need to create a variable. So like in the previous lessons we have covered how to use the variables. Now we are actually using that in our scenario. So how to create a variable? You just have to do variable, give the variable name as VPC ID, and inside that, so type equal to string, and you can give default equal to your VPC ID. Alright, now we need to specify that VPC ID here, so we can say it is var dot VPC ID. Now to use the variables, all you have to do is dollar, inside double quotes you have to do dollar open curly brace var dot VPC ID, and you should be able to access this particular resource from here. Now you have a ingress and egress. Ingress is basically inbound and egress is basically outbound. Now you can have many rules by specifying many ingress rules, and you can have many egress rules. Now there are again a different ways to specify rules. Now you can, in your security groups, you can have multiple cider blocks, and you can have let's say you can allow rules to a different security groups, and so on and so forth. You can choose from different protocols. Now what we can do is we can say for port 22, which is our SSH, we are just going to say from port 22 to port 22, which is basically saying like, okay, I just want port 22 open, and protocol is we want TCP, right? We want TCP. If you go here and see what are the available protocols, let's search for protocol. You can see you can see protocol, if not ICMP UDP -1 use protocol. So you have to use TCP because we want TCP port 22, because we want to SSH into that instance. So we are saying allow port 22 open from everywhere. Now you can specify your own IP address. For this example, I'm just leaving it to all open, which is not a good practice, by the way. You should never use this kind of thing in your production, but for this example, I'm just gonna leave it open because we're gonna tear down that environment anyways at the end of the lessons. So that's one thing. And in the egress, one other thing is, if for in your security groups, if you have something open inbound, then for that specific thing you always have that outbound path open by default if you have something inbound open. But we just specify outbound rule as well, just so that we can play around with this. And you can say in the CIDR blocks, yes, I want to open everything, and I'm just going to get rid of this. Alright, so now you have a security group which is Terraform EC2 SG should be created. Now let's go ahead and run this Terraform script. Now to run that, all you have to do is open your PowerShell, and I have my PowerShell open here. Now inside this, we want to go to our folder, right? So inside this, we want to go to our EC2 Terraform, clear. Now let's do Terraform init, because you have, this is our new Terraform file. We have to do initialize first. So let's do Terraform init. It's taking a bit. Alright, so we have our Terraform initialized. I'm just going to clear the screen again. We are going to do Terraform plan now and see what it comes up with. Alright, we don't have any errors. It's saying basically we are creating a we're adding one resource, 0 to change, 0 to destroy, and we have a security group that we're creating, and we are specifying one egress rule and one ingress rule. So you can see egress number 1, ingress number 1, and you're adding those resources. So now you can clear again. You can say Terraform apply, and it will ask you for the confirmation. And once you type in yes, your new resource should be created, and we can go back to the AWS console once it is created to verify if that new security group has been created or not. Now let's go back to our AWS console. Now go to our security groups, right? If you go to security groups, search for Terraform. Alright, so you have security group name Terraform EC2 SG, Terraform Course SG for EC2 instance. That's what you have created. And inside the inbound rule, you can see that you are opening SSH port 22 in TCP protocol and from everywhere. And you also have the same outbound rule specified here. Alright, so the first part of the EC2 instance is completed. Now let's go ahead and actually launch a EC2 instance. Now to do that, I'm again going back to my Terraform documentation. Now I'm going to search for AWS underscore EC2 underscore AWS underscore instance. So if I go here, now I'll be seeing an example for how to launch an EC2 instance. Now if you see resource, AWS instance, web, and you need an AMI. Okay, so there's one more dependency here. We need an AMI. So to get the AMI, we can use the latest whatever the EC2 Linux AMI which AWS offers. In your case, if you have a specific AMI that you have created, you can copy that AMI ID from images section. But in this case, I'm just going to AMIs, You can search in it in a couple of ways. We can go to owned by, we can actually go to this. We can search for AWS Linux, and we want vendor as Amazon Web Services, and you can see Amazon Linux AMI. I'm just going to choose that, and to get the AMI ID. Now let's go ahead and search for the AMI ID. You know what, the easier way to find out this would be just going to instances, Launch EC2 Instance, and this is going to show us the AMI ID from here. Now I'm just going to choose this AMI ID, copy it, come out of this page. Now go to my Terraform file again, and inside this I'm just going to specify another var, which is variable AMI ID, and inside this there's no need to specify string if it is string, so I'm just going to leave it as default equal to this particular AMI ID. Alright, so now we have the AMI ID, and let's go back to the documentation again and see what else we need. So alright, so we can just copy this block, which is saying a resource AWS instance, and we can name that instance something. We can go here, copy that. So we are saying AWS instance, we can call it Terraform EC2 Instance, and we can specify this as var.AMI ID. Alright, we can choose the instance type t2.micro. You can specify whatever the instance type you require, and we can say name as these are the tags that we are specifying, so we can say tags name equal to Terraform EC2 Instance. Alright, and you can also specify many other attributes. Let's go ahead and check it out. So we can specify which availability zone. This is optional. If you specify a specific availability zone, it's gonna create in that. If not, it's going to randomly choose one. If you want placement group, you can choose that. Default tenancy is basically shared. If you want a dedicated host, you can choose the tenancy as the single tenant. You can specify number of CPU core counts, these all, and you can specify EBS optimized. You have many other inputs that you can give. One other input that we want to give is basically the key name, because we have created one key and we are going to use that key name, and also we are going to specify the security group for this. So let's choose the key name option here, and in here let's go ahead and check out specify the key name. If I remember correctly, let's go ahead and go to our EC2. Let's go to the key pair and select this key pair, which is Terraform course. You can copy that, paste it here. Now let's go back to our Terraform documentation. Now inside this we are going to say a list of security groups associated with default VPC only, a list of security group names or IDs. Alright, so we can say we want security groups because we are using the default here, and you can specify IAM instance profile if you are passing in the IAM role, and there are many other things that you can specify here, like EBS block devices and so on and so forth. So for now we're just going to say we're choosing all the defaults. So in security groups, it's a list of security groups because you can have multiple security groups assigned to a specific instance. So I'm going to specify it as an array, and inside this we are going to specify $, and we are going to say AWS security group, right? dot this resource name, which is EC2 SG, and I think it is ID. Let's go back and verify it, how the security group is outputting its variable as. So I'm going to duplicate my documentation here, going back to AWS security group. Now we have to check the data, right? So because data sources, we want to see how the security group is outputting the data. Now you can see so if you see, okay, the ID of the specific group to retrieve, so that's what it is going to output. So we can just say go back here and say ID, and that should be pretty much it. Now if you go ahead and run your Terraform script, now you should see one resource to add. Let's clear this out and run the Terraform plan. Alright, so there are no errors, and it is basically telling us that it is launching an EC2 instance with most of the default values and the values that we have specified. Let's go ahead and apply it. So clear Terraform, apply. Alright, so it's asking for a confirmation. Just type yes. And once you typed yes, okay, so possible mismatch security group IDs and names, see AWS instance docs here, value parameters group ID is invalid. Alright, something is wrong here. Let's go back and check what's happening here. So we are saying security groups equal to we need to specify a list of security groups. So that's what we are saying here. Let me go back and check. So security groups equal to, we're specifying list. Let's go back and double check. Not this. We have to go here to check for security groups. Okay, the associated security groups. Alright, we have security groups. We have it open, close. Alright, so maybe this is because it is not a default security group. Let's check for VPC security group IDs, and let's see how this works. Alright, so let's go back and do Terraform plan again. 39. Okay, I'm accidentally deleted this. Oh, I think this is because of the length. Alright, so let's save this, go back here, do a Terraform. Oh, I missed a double quote here. Let's clear this, do Terraform plan again. Alright, refreshing state, Terraform apply. Hit select yes. Alright, it is now creating the actual AWS instance, and once that is created, you should get back the instance ID. And let's see. Alright, so you have one resource added. Now if we go back to our AWS console, you should see a new instance being launched. If I go to instances, alright, you can see that Terraform EC2 instance has been launched, and its instance ID, it has the t2.micro that we have specified. It choose the random availability zone EU West 1B, and it has chosen the key name Terraform-course. Now, if you would have specified user data, it would have run some bootstrap scripts, but we haven't specified, and it has applied the Terraform EC2 security group. And the reason why the previous attempt failed is because we used the block of security groups, which is basically the default one. We need to use VPC security group IDs because we have created a non-default security group in a default VPC. So that's pretty much it. You can see that now you have launched an EC2 instance. You have also seen how to use the variables properly and how to kind of get hold of those variables in a specific AWS resources. So that's it for this lesson, and this is a really long lesson, and I really hope that you enjoyed it. And if you have any questions, you can ping me in the course and I'll be happy to answer. And thank you so much for watching, and I will see you in the next one. Bye bye. Hello and welcome back to the conclusion lesson of this section. And in this lesson, I am just going to give you a quick walkthrough of what we've done in this particular section, and I'm just going to give you an introduction to what we are going to cover in the next section. So let's get started. So in this section, we have seen how to use how to create the basic AWS resources using Terraform, like creating an S3 bucket, uploading a file to S3 bucket, and also we have created an EC2 instance, and along with that we have also created the security groups. Now this the whole goal of this particular section was to just get you an understanding of how to create AWS resources using Terraform, and also how to implement some of the concepts that we have learned in the previous sections, like using the variables, etc. And also we have seen how to go through the Terraform documentation to figure out what are the required properties that you need to supply to create your resources. Now you will basically apply the same concept to create any type of resource in AWS using Terraform, and it's pretty much straightforward. Now that you know how to create the resources, let's go ahead and learn in the next section the proper ways of using Terraform. I mean the advanced concepts, in which I will teach you how to use modules, how to have a good folder structure for your enterprise level infrastructure, and different concepts that are really important to have a very good manageable Terraform. And I really hope that you enjoyed this section, and I'm really excited for the next section because there's a lot of good stuff that is coming over in the next section. So I will see you in the next one. Thank you so much for watching. And if you have any questions related to this section, you can always comment on the course, and I'm really happy to answer those questions. And also, if you feel that there is something missing, or there is some really important concept that you would like me to cover, then you can always ping me in the course, and I will be more than happy to add that particular information to the course. And if it is a extra lesson, I am definitely open to add more lessons to this course, because the ultimate goal of this course is to make you a better user of Terraform. And if you need something, I am really excited to help you out and get more content onto the course, so that it is more helpful to all the other students who are participating here. So that's it for this lesson, and thank you so much for watching, and I will see you in the next section. Bye bye. Hello and welcome back to another lesson in #learning courses. And in this lesson, let's look at what Terraform modules are and why we need the modules. So let's get started. So the first thing that comes to my mind when we say module is basically separation of concerns, right? So when you have a big infrastructure that you want to provision through Terraform, you would like to basically separate it out into smaller segments so that it is easy to manage, and also you can construct reusable components so that you don't have to repeat the same code again and again, and instead use a module so that you can reuse that within your main Terraform and reduce the code that you are writing to achieve the same task. So to give you an example, let's say your big infrastructure has a load balancer that needs to be configured, right? So if you want a load balancer to be configured 4 times, right? So if you have a set of workload which needs 4 different load balancers, you don't want to write like the same load balancer logic 4 different times. Instead, what you do is you'll separate it out as a module and you'd give its own input variables, and you'd say from outside that, okay, I need this module with so and so inputs and this module with so and so inputs, and you just reuse that particular module. Now I'm just giving a small example. In your case, it might be a set of infrastructure where you have a load balancer, you have an autoscaling group, and a CloudWatch alarm. Let's say you separate that all out into a module, and you can reuse that whole component in a other Terraform by just calling it and supplying it with the required variables. Then you'll have a smaller code which is easy to manage, and if you want to change something, you don't have to change it many different places. You'll just change it one place, and that would basically change in all the places wherever the particular module is being used. So that is why we need modules, and it is really important to understand this concept so that it becomes very easy for you to manage your infrastructure, and it is a right way to handle the infrastructure. So I'll stop this lesson here, and in the next lesson we are going to go ahead and see how to create this modules and how to import a specific module into another Terraform file. So I'll see you there. Thank you for watching. Hello and welcome back to another lesson in #learning courses. In the previous lesson, we have briefly discussed what Terraform modules are and why it is important for us to use the Terraform modules. In this lesson, let's go ahead and actually create our first Terraform module, and let's go ahead and see how to import a specific module and run our Terraform scripts. Now, before we go ahead and create our project, I just want to give you a quick walkthrough of like what the documentation looks like, and then we'll go ahead and create our project. So you can basically go to terraform.io site, and you can go to the docs section, and to the left hand side you should see the modules part here, and you can basically go ahead and read more if you would want more information. And you can see the sources, different sources where you can store your modules and then re-import them again in your different Terraform projects. You can have registries and so on and so forth. You can read more about it if you are really interested in how to do the modules and so on. So let's go back and create our first module. Now the objective of this module would be basically, first we'll create a module, and in that module we are going to create a EC2 instance. Now in our previous section we have created an EC2 instance using the Terraform. Now in this lesson what we are going to do is we are going to do the same creation of EC2 instance, but instead of writing everything in the same main.tf file, we are going to create a module to create that EC2 instance, and we are going to import that module in our main.tf and recreate this same EC2 instance. So to do that, let's go ahead and get started. So the first thing that we have to do is we have to create our project folder. I'm going to use the same directory where I've been working for the previous lessons. So I'll create a new folder here, and I'll call it EC2 modules module project, right? So inside this we have to create a new Terraform file, which is going to be our main.tf instead of txt. Okay, so now what I'm going to do is basically to create a module, right? So the module is another Terraform project. It could be within the same project that you're working, or it could be anywhere else too. Like we have seen in the documentation, you can clearly see that different sources are local paths, Terraform registry, GitHub, Bitbucket, or HTTP URLs, wherever that specific module exists. So in our case, what we are going to do is create the module in the local directory and within the same project. So what I'm going to do is I'm going to go ahead and create a new folder, right? Inside this, what I'm going to do is EC2 underscore module. Let's keep it simple. Now inside this EC2 underscore module, I'm going to create another file which is going to be EC2 underscore module dot tf, right? Okay, so now our project directory is all set up and ready. I'm going to just go ahead and open this folder inside the Sublime edit. Oh, I think we already have it open, but let me just be sure about it. Okay, open folder. We want to open this folder and open it, right? So this is the project that we are working on right now, and the first thing what we have to do is basically go ahead and create our provider. Now, how do we create a provider? We have done so many times in the previous lesson, so I'm just going to copy this provider part from our previous project and pasting it here. So let's go ahead and initialize our Terraform project. So I need this path. So now I'm in the course directory. I'm going to go into the cd EC2 module project, right? So these are the contents that we have. Let's clear out of here and do a Terraform init. Now when we do the Terraform init, it actually creates the downloads all the plugins that are required, and once the plugins are downloaded and ready to be used, it gives us this success message. So we can just clear out from here, and let's go ahead and write our code which is required in our module. So the goal is to recreate the EC2 instance. So I'm going to go back to my EC2 Terraform project, and from main.tf, I'm just going to grab everything from this code, right? I just left the provider and I've copied everything that is there required for the creation of our EC2 instance, and I'm going to go back to my EC2 module project, right? Inside this, you will go to EC2 underscore module and EC2 underscore module dot Terraform. Here, I'm just going to paste everything, right? So now if you notice, all we did was separated our code from our main.tf and put into a separate module file, right? Now the next thing that you're going to do is go to main.tf and you have to import this particular module. Now how do you import this module? It is really simple. All you have to do is write module, and you have to give that module a reference name, right? You have to give it a reference name as module, right? And you're calling it as and you have to give it a source. Now source equal to, now as it is in the same folder directory, you can just say /ec2 underscore module, right? So you're in the same directory and you have included this. Now if you go ahead and run Terraform plan, now this command is going to fail because now you have added a module and you have not initialized it, right? So whenever you add a specific module to your Terraform project, you should always do a Terraform init. So to do that, I'm going to run Terraform init, and now it is going to import that particular module. You can see that it is getting the source from /ec2 module, and it has applied to our particular project. Now if I clear out from here and do Terraform plan, now it's going to tell me that we will be creating a two resources. One is basically the security group and the EC2 instance, right? The security group and the EC2 instance. Now let's go ahead and run this Terraform apply. All right, so when I do a Terraform apply, it's going to ask me for the confirmation. I would just say yes, and once I type in yes, it's going to create All right, so the problem here is basically in the previous example, as we have created this EC2 underscore SG security group, Terraform EC2 SG security group, we cannot recreate the same resource because it is already existent there. I haven't deleted it. So what we can do is go back here and give another name saying SG underscore module, right? So it makes sense to give it a module. And then what we are going to do is Terraform plan. Oh, okay. Let me go ahead and fix this. So we have to give the same name here, right? So this is our reference name and this is the resource name, and we are calling this in the EC2 section here. So we'll have to replace this name here and then save it. All right, so now if I go back and do Terraform plan, okay, so we have two resources that we are creating, Terraform apply, and we are going to say yes. Okay, so our security group is now being created, and we can see that we have our new EC2 instance also being created in just a bit. Right, so EC2 instance is being created. This might take a couple of minutes. I'm gonna pause it here and like come back once it is ready, and I'll show you in the AWS console. All right, here we go. So our EC2 instance must have been created. Now let me go back to my AWS console and let's verify if that new EC2 instance has been created or not. All right, so you can see that the new EC2 instance has been created, which is being launched here, and I think I haven't destroyed my previous instance, so I'm just going to terminate the old one. This is the new one that we have created, and yeah, so basically this is how you can use and create a module. And in the next lessons we are going to go ahead and experiment more on like how to give inputs and how can you have multiple modules and how can you import the same modules over and over again. So that's pretty much it for this lesson, and I am going to see you in the next one. Thank you for watching. Hello and welcome back to another lesson in #learning courses. And in this lesson we are going to continue off from our previous lesson where we have created our first Terraform module, and we have created an EC2 instance using a module, right? So in this lesson what we are going to do is modify our existing Terraform project and refine it more so that we can supply some input variables to that particular module, and we can also separate out the security group out of that EC2 module so that we can have more control over what security groups gets created and how we can pass in that security group variable that was created in a separate module and input it as an input variable to the EC2 module. So let's go ahead and see how it is done. So what I'm going to do is I'm going to open up my project folder, and I'm going to duplicate this project folder because I don't want to create it in the same one. So I've duplicated it and I'm calling it as part 2, right? So inside this we had all this state files which we don't need all this, right? So now we have a clean copy of our previous project, and what I'm going to do is I'm going to create another module which is going to be my security group module, right? So this is our security group module, and inside this we need another Terraform file. So we are going to call it sg_module.tf, right? So again I'm going back to my course folder, and I am opening my Sublime edit, and inside this now we are working in this part 2 project folder. So let me go ahead and clean up some of this module so that we have two separate modules, and we have to add an import statement for that module in the main.tf file, right? So the stuff that I want to separate is, like, if you go to the ec2 underscore module.tf, you can see that we have a resource called security group, which needs this dependency of VPC ID. Okay, so we can see that VPC ID is an input to this particular resource, which is security group, and also it is a input to our did we give input as VPC ID here? Just trying to see. Okay, so this guy doesn't need that VPC ID, right? So what we can do is we can separate this part out, right? I'm doing a cut from here, and you can see that this has been separated, and we'll put that in the security group module, and we can save it, right? So we're not supplying any input to this particular security group module, but we have to do an output variable from this particular module, right? So the way you will do an output variable is, basically you can say, like in your previous lessons, if we go and you can just say output, you can call it security group ID underscore output, and you can say the value is, basically you have to do dollar open close, and you're getting the value from Terraform. If you go to your EC2 module, you can get the value as this guy, right? So this is the value that we want to export. So basically what we are doing is we are referencing to this AWS security group, and inside that we are referencing our module name, and we are calling the ID from it. Let's do it this way so that it is visible, everything in the same line. All right, so here what we have achieved so far is we have a security group module which doesn't take any input, but it's going to create the output variable. First it's going to create a security group, and it's going to create an output variable. Now we have created this security group in the previous example, so I'm just going to change the name so that we can say security group module creation, right? And I'm going to rename it here, and we are going to change the name here. So now we have our security group being created as SG module creation, and it is being outputted as the SG ID output. All right, so now what we have to do is go back to our main.tf and basically import this specific module. Now we have to import this module before we import the EC2 module, because what we are trying to do is we are trying to create the security group in a separate module, get the output of that, and supply that output variable as an input variable to the EC2 module so that it knows what security group it has to attach to, right? So we are going to import module, and we are going to call it SG underscore module, and we'll give the source, which is source equal to ./SG underscore module. All right. Okay. So now we have imported we have included this SG module as a dependency in this main.tf. Now once we do that, we can go ahead and reference this particular module and read all the output variables from it. Alright, so the way we'll read this particular output variable and supply it into this guy is we have to create a variable first inside our module so that it knows that it is expecting an input. So the way you'll do it is basically go to your EC2 underscore module.tf here, and you'll create a variable, right? So you'll create a variable saying sgid. Okay, let's call it sg underscore id, and you'll just give open and close. That means you don't have any default variables here, but your this particular module expects this as an input. And what you can simply do is instead of using this, we'll just call var dot sg underscore id, right? So now you're saying I'm expecting this input and I'm supplying that input to this particular EC2 instance. And also let's change the name and supply it as an input, right? This is just to do more practice on inputs, right? EC2 underscore name, and these are the two variables that will be supplying the input as, and we'll have to change the name here. We'll say we'll say EC2 var dot EC2 underscore name. All right, so this part is now complete. All we have to do is go to the main.tf and supply our input variables to this particular module. So the way you will do it is the variable names are sg underscore id. So you'll just say sg underscore id equal to, now this is being outputted from this module. So you have to do is inside double quotes dollar open close, and inside this you'll say module dot, and you'll reference the module that you're importing it from. So module sg underscore module dot, and whatever the output name of that particular variable is. So this is the output name, and we'll just have to do this. So we have module dot sg module and sg underscore id output. So that's the id that's been created in the previous step. So, and the other one that we have to include is the EC2 name, right? So we'll copy that and we'll paste it here, and we'll give it saying that EC2 instance from module, right? So this will be the name tag that we'll give to our EC2 instance, and let's go ahead and see whether this works or not. So the thing that we have to do is go to our project and open up Terraform, the PowerShell console there, and go to the project folder, which is our part 2 project. You can see that you have 2 modules there. Now we have to do is do Terraform init, so that it includes 2 modules, which is your SG module and EC2 module, and it's also going to install the provider plugins, which is essential for this project. Okay, so the project has been successfully initialized. Let's clear here and do a Terraform plan. Now we should again see 2 resources being created. One is the security group and the other is the EC2 instance. And you can basically see that we are creating 2 resources here. Let's clear here and we'll do Terraform apply and type in yes. Okay, so I'm going to pause here because it's going to take a few minutes for it to complete. Oh, so there's something wrong here. So it's saying EC2 instance error launching, instance invalid key pair not found, EC2 instance from module does not exist. All right, so let's go back and check what error we did here. So did I remove something wrong from here? Oh, I'm sorry. So I've changed the wrong variable here. So this is Terraform course is our key name, which is the key pair that which you'll use to retrieve the passwords and SSH into the instance. So we have to apply it here in the tag variable, right? So we have to go and do we have to call it var.ec2 underscore name. Now if I save it, clear this, do Terraform plan again. Now you can see that there is only one resource to be created because we already have created the security group in the previous step. So there is only one resource which is pending. So we can do Terraform apply, and you can just do yes here, and you should see that the instance will be created. So I'm going to just pause it here, and once the instance is created, I'm just going to come back and show you it in the console. Alright, so our EC2 instance is now created. Let's go back to our console and do a quick refresh, and you should be seeing a new instance being launched, which is EC2 instance from module. Now we have supplied this as an input to our module, and we have created a new security group, which is basically SG underscore module creation. And if you click on this, you can see that all the rules that you have supplied here are applied to this, and that's pretty much it. Now you basically have learned how to create multiple modules and give inputs to those modules, and how to output a specific variable from a specific module and supply it as an input to other module. Now this is a really important concept because you can extend this particular concept to manage very large infrastructure where you have so many components, and they are all dependent on each other, and you don't want to write the same code again and again or hard code the variables so that it is very hard for you to manage when you are updating any specific component of your infrastructure. So I'm going to stop this lesson here. I really hope that you guys learned a lot from this particular lesson, and in the next lesson what I'm going to do is I'm going to show you how to reuse this particular module in the same project and create multiple EC2 instance by calling the same module with different inputs, like giving it different names, right? So let's go ahead and close this lesson now, and I'm going to see you in the next one. Thank you so much for watching. Hello and welcome back to #learning courses, and in this lesson we are going to see how to reuse the Terraform modules. Now in the previous lesson we have created two modules, which are security group and EC2 as modules, and we have imported them in the main.tf file. Now what we are going to do is, now we are going to create more EC2 instances by just using the same module, right? So we are not going to touch the EC2 underscore module .tf. We are just going to touch the main.tf file, and we are going to create another EC2 instance using the same module. So let's go ahead and get started. So the first thing that I want to do is open up my will be in the same project folder. I'm opening up my Terraform PowerShell and my Terraform folders. All right, so the first thing that I want to do is like destroy the instance that I've created previously. So I'm going to do Terraform destroy, right? And it will ask me for a confirmation in just a bit. All right, so this will be destroying the EC2 instance and the security group that it created in the previous lesson. Okay, so one more thing that I want to mention here is the the state files, right? So when you are working in modules, you will not have state files for each specific module. Now, if you go into your module folder, you'll see nothing here. There is no .tf backup, or there is no .tf state file. Everything is stored in the main state file itself, right? So all the modules information is stored in this main terraform.tf state file. I can even open up that particular file and show you what exactly is created in that, right? So if we go here and open up terraform.tf state file, oh, there's nothing left because we have already destroyed, but I think there should be something in the backup file. Yeah, so if you go here, you'd see that there are this is the root module, and there is nothing in here. All we have done is, like, we have created we have imported the resources. I think this is the backup. This doesn't give us a good idea, but after this lesson, I'll show you how to actually check the Terraform state file and how the modules are separated within the state file. So let's clear this up and let's get started. So the first thing that we will do is go to the project folder itself. Let's close everything. Okay. And the one which we are interested in is just the main.tf file. Now here what we are going to do is, we already have the EC2 module and the security group module. We are just going to replicate this particular module, and we are saying, okay, we want another copy of this EC2 module, right? And we are going to call it, we'll say EC2 instance 1 from module, and we'll say EC2 instance 2 from module. Now this will end up in creating two different EC2 instances for us. So we'll call it EC2. We'll call this 1. We'll call this 2. This is just the reference name to your module import, right? So once you save this, all we have to do is go to Terraform, go to PowerShell and run the Terraform init. The reason why you have to run the Terraform init is, again, like I said in the previous lesson, whenever you add a new module or whenever you re-import a specific module, you have to run a Terraform init so that the Terraform figures out that there is something new module attached to this particular main.tf. So once you do a Terraform init, you can see that there is EC2 module 1, EC2 module 2 being imported from the same source, right? So you're reusing the same module now 2 times, and it has been initialized. Now we can clear this, we can run Terraform plan. Now you should see 3 resources being created. One is the security group and the 2 EC2 instances, right? So you have 2 EC2 instances, 1 security group. Now you can do Terraform apply, and it's going to create these 3 resources. Type in yes, and once you do this, now it will create the resources as specified. I'm going to pause this lesson here, and I'm going to come back once the EC2 instances are created. All right, so after a few minutes, the EC2 instances are now created. Now let's go back to our console and check if they have completed provisioning. Now I just hit a refresh, and now you can see that EC2 instance 1 from module, EC2 instance 2 from module are created, and they are being initialized, and that's pretty much it. Now you have reused your module, and you have supplied different inputs to that, and you have created multiple resources out of the same code. Now, like I said in the beginning of the lesson about the state files, now we can go ahead and check our state files. You should see that there is only one particular state file here, and there is no state files associated with any of the modules here. And if you look carefully in the module section here, you should see that there is a root path, and inside root path Okay, so the path is basically root and EC2 module 1. So inside first module there is nothing. We don't have any resources. In the second module, the path is basically under root. You have EC2 module 1, and you have the EC2 instance resource being created. And in the second module you have again root and EC2 module 2 that you have imported, and its particular resource. And then you have the security group module. Then you have all the variables related to that particular EC2 module here. So that's pretty much it. This is how the state file looks like when you use the modules. And I think you have learned a lot of information from this particular lesson, and I really hope that you can apply these techniques in your real projects and get the best out of the modules in your infrastructure. So that's pretty much it for this lesson, and I will see you in the next lesson. You can ask me any other questions if you have in the course section, and I'll be happy to answer all those. Thank you for watching. Hello and welcome back to #learning courses, and in this lesson we are going to learn about multiple environments problem. Now, what do I mean by multiple environments problem? So in any enterprise level infrastructure, you can see that there are different environments of your infrastructure. Like let's say you have a development environment, you have your QA or staging environment, and then you have your production environment. Now the key factor here when you have multiple environments is basically to have consistency across different environments, meaning you should have your infrastructure identical across different environments. Now if it is not identical, then basically you're not testing against the same infrastructure. For example, let's say you have a load balancer configured using a classic load balancer in your dev environment, and you are using an application load balancer in your staging and prod. Then what you are seeing in your dev, the results that you're seeing in your dev environment, or the performance metrics that you're seeing in dev, might not match the performance metrics in the QA environment. I mean, this is just a hypothetical example, but like you can also think about the security groups. Let's say you've created a security group with a port open in your staging, but then you forgot to open that particular port in your production environment. Then you have a problem, right? When you test in your staging, it's going to work, but if you promote it to production, then it's not going to work because the port is closed. So to avoid these kind of situations, we have to have our Terraform script to be used across different different environments using the same Terraform file. Meaning you'll write the code for your infrastructure saying that I need this security group, I need a load balancer, I need an autoscaling group, and all the these are all the properties that I want to apply to it. But what you're going to do is you're going to give it environment specific inputs, and it is going to create different resources based on what environment you are on in. So this is achieved by using the feature of Terraform called Workspaces. Now using Workspaces, you can create different workspaces in the same Terraform project, and you can work on specific workspace at a time, and you should be able to create or modify resources in that particular workspace, and then once you're satisfied, you can apply it to the other workspaces. Now I'll give you an example of how you can use workspaces to solve this multiple environment problem. Now let's say you create 3 different workspaces for the same Terraform file, and what you'll do is, like, first workspace would be your dev, and you create that workspace, you apply your resources, and then all resources are provisioned. Now once you verify that everything is fine, then you'll select your staging workspace, and you'll apply your resources there. And once everything is done, you'll apply it to the prod, and everything is working fine. Now at the end of the day, you want to make a change, and you want to test it in dev first, right? So you'll switch back to your development workspace, you'll make your changes, and you will apply it and see that, oh yeah, this is working fine, this is the required change that I need, and I need to promote this to QA. All you have to do is like again change back to the QA workspace or the staging workspace, run it there, verify it, and then promote it to prod. Now what we have achieved in this process is basically consistency across multiple environments, and there is no doubt that whether we have missed any of these properties and if there is any mismatch across different environments. So Workspace is a way to go to solve the multiple environments problem. I'm going to stop this lesson here, and in the next lesson we are going to talk more about workspaces, and we'll see how workspaces are created and how to switch between different workspaces and how the Terraform state files are managed for different workspace environments and so on and so forth. So I'm really excited to start this workspace concept because I really enjoy it, and it is a really useful piece of information that you can apply in your enterprise level projects or even your personal projects to manage your infrastructure in a more consistent way. So that's it for this lesson. I will see you in the next one, and thank you so much for watching. Hello and welcome back to another lesson in #learning courses. In the previous lesson, we have discussed what the multiple environments problem is, and the way to solve it is using the Terraform workspaces. Now, in this lesson, we are going to go ahead and check out how to create these workspaces in our projects and also apply these multiple workspaces to create multiple resources in different environments. Using the same Terraform scripts. So let's go ahead and get started. So the first thing that I want to tell you is basically we are going to use the same existing EC2 project that we have created in the modules part, and we are going to create new workspaces for that specific project, and we are going to modify bits and pieces of that project to accommodate the workspaces there. So let's go ahead and get started. So the first thing that I want to do is create a copy of that existing modules project. So the existing modules project is this EC2 modules project part 2. I'm just gonna copy and create a new part, and I'm gonna rename it as basically EC2 workspaces project, and let's go ahead and do some cleanup in here. So I want to delete the state files. I don't want this particular file here. Okay, so now this is in a clean state. Now let's open the PowerShell prompt, and inside PowerShell prompt, let's go to this cd ec2 workspace project. Okay, now we are here, and the next thing that I want to do is open up my project in the Sublime text, and inside this you can see that you have this EC2 workspaces project that we have created. So now let's go into the main and clear out this module because I just want to create one EC2 instance. Alright, so now we have the project structure ready, and we are now ready to create the workspaces. Now usually when you are creating a big infrastructure project, I would suggest you to create the workspace first and then slowly build your environment. But for in this example, we are going the opposite way because we already have the project and we are creating multiple environments, and then we'll accommodate the code accordingly. So okay, so let's go ahead and create our workspace. So to create a workspace, you need to be in that particular project folder where you're executing the Terraform, and you need to execute this particular command, which is called Terraform Workspace new, because you're creating a new workspace and you have to give it a name. So I'm gonna call my environment staging, and you can see that you have now created an environment called staging, and your workspace is now selected as staging. Now I also want to create another workspace called production, right? So I'm gonna do Terraform Workspace new production, right? So you have now staging and now you have production. So firstly, I want to show you the list of all the environments that are created here. So to do that, you can do Terraform Workspace list. Now when you do this list, you can see all the environments that are available here. You have the default environment, that's the default when you create any Terraform file, and you have created a specific environment called production, and you have created a specific workspace called staging. And you can see that there is a small asterisk here which tells us that that is the workspace which is currently selected and it is being used. Now to switch between workspaces, all you have to do is run this command Terraform Workspace select staging. Now you should see that it's switched to the workspace staging, right? So let's go ahead and work in this particular environment first, and then create a resource, and then switch the environment and create another resource, and we'll see that how you can create multiple resources in different environments with the same Terraform file. So let's go ahead and switch our clear this PowerShell here, and let's go ahead and write some code which gives us the capability to detect which workspace that we are working on right now. So here I'm going to show you a concept of local variables. The locals variable is nothing but you can have some specific variables that are only to this only related to this specific module or specific file. So to declare locals variable, you can all do is locals, and you have to open and close here, and inside that you'll just declare some variables. So in this case, I'm just going to do environment, and this will hold the value of what workspace we are currently active on. So to get which workspace we are currently active on, all we have to do is terraform.workspace. Now this variable will give back which workspace we are working on, and it is being assigned to environment. Now how can we create multiple resources with the same Terraform file? Is basically you need to configure your project in a way such that it's all controlled by variables, and all the properties are chosen based on a specific value like this environment, and then that particular value is being assigned as a property to the resources that are being created for that environment. So I'll explain that to you by an example. So let's say now you're creating this EC2 module here, and let's go ahead and edit this security group module, right? And inside the security group module, what we can do is we can take the name here, right? And we can say that we want to give variable SG underscore name, and here what we can do is, instead of this hard-coded name here, we can give $var.sg underscore name, right? So now what we have to do is we have to supply this name from an external source, which is wherever the module is being called. So I'm gonna say sg name equal to sg specific security group EC2. We have to give an environment. So how do we call this local environment? All we have to do is we can do $, and we can reference it by saying locals dot environment. So this is not locals, this is actually local dot environment, and we are going to do the same thing for the EC2 instance as well. We are going to say EC2 instance underscore we're gonna call again the local dot environment. All right, so what we are trying to do here is we are creating two resources, which is our security group and our EC2 instance, and both are different modules, and we are saying that we want to create names that are specific to a specific workspace that we are working on right now. So if we are choosing a staging environment, then when we execute this, we'll get the security group as security group EC2 staging, and the EC2 instance would be EC2 instance staging. Similarly, when you execute the production, you'll get this values as SG EC2 production, EC2 instance production. So let's go ahead and run the Terraform and see the outputs, and let's get started. So I've saved this, and let me go to the Terraform project. Currently we are already in the staging environment. The way you can confirm that is by running the command Terraform Workspace list, and if you can see that you are currently active in the staging environment, let's clear this and do a Terraform init. So now when you do a Terraform init, it initializes and includes all the modules that you have declared, and once the plugins are downloaded and ready, you can go ahead and run your Terraform plan and apply. So let's clear it from here. Let's do Terraform plan. You should see that it's creating 2 resources, and if I'm not wrong, you can see that you already got the name SG-EC2 underscore staging. You can see that EC2 instance staging. Now this has been computed in the real time, in the runtime when you selected the specific workspace. Now we can do Terraform apply, and when you're applying, it will actually tell you that you are in the staging environment and do you want to apply these changes. Yes, I want to apply these changes, so I typed in yes, and now it's going to create this EC2 instance. I'm going to pause this for a second, and once it is ready, I'm going to come back and show you how it looks in the console. Alright, so now we have our resources created. Let's go to EC2 console and check if they are actually created. So let me refresh this console here. You can see that the EC2 instance staging has been created, and when you select that, and you can see that the appropriate security group is also now created, which is EC2 security group EC2 staging. Alright, so now we have our staging environment set up. Now we are sure that everything is created according to the plan. Now let's go ahead and push this to production, and the way you'll do it is basically going to your Terraform project folder, and you'll select Terraform Workspace, select production, and you can see that your workspace is now switched to production. You'll do the same thing again, Terraform init. Now it's initializing the modules, and you can do Terraform plan. Now you see it's creating 2 fresh new resources because the properties are changed and you're giving different inputs here. Now you can see that the names are SG EC2 production and EC2 instance production. Now you can go ahead and do Terraform apply, and then you can apply the change. And again, I'm going to pause this and then come back once it is created. Alright, so now this production EC2 instance is also created. Let's go back to the console and verify if we got the new instance or not. So let me open up the EC2 instance console. So you can see that EC2 instance production is also created, and you can see that appropriate security group SG EC2 production is also created. So this is how the workspaces work, and you can basically use the same Terraform script to create multiple environment stacks so that you have a consistent environment. You have a consistent infrastructure across environments created, and it is easy for you to maintain and manage them. So that's pretty much it about the workspaces. Now I'm going to show you how the Terraform state files are maintained in this workspaces concept, and in this next in the next lesson, then we'll see many more tips and tricks that I have learned in my experience, which are not available directly in the documentation. So don't miss those parts. So let's go back and check how the Terraform state files look like. Now you can see that let me go to this part. All right, so you can see that here you have terraform.tfstate.d, right? In the previous projects you have seen that the Terraform state file is directly under the root folder, but here you have terraform.tfstate.d folder, and inside that you can see that there are two different folders, which are staging and production, right? And each workspace has its own Terraform state file, so any resource changes that you create for that specific workspace are tracked in its own specific Terraform state files. So that's pretty much it for this lesson. I really hope that you enjoyed this lesson, and I'll see you in the next one. Thank you so much for watching. Hello and welcome back to another lesson in #learning courses, and in this lesson we are going to look at what is environment specific local variables and how to create them. Now, as far as I know, there is no documentation related to this. I have tried a lot of I've done a lot of trial and error to figure this out for myself and my use cases, and I just wanted to share this because this hack will really help you in creating the environment specific local variables. Now let me give you a use case where you can use this concept. So let's say you have have three different workspaces like staging, dev, and production, and you want to launch three different EC2 instances with different AMI IDs. Now, how do you specify which environment will use a specific AMI ID? So that is what we are going to solve here. So let me open up the project, and let's get started by solving this problem. So let's go into our project. So I'm going to use the same project that we have used in the previous lesson. We already have staging and production workspaces created for this project. Now let's go ahead and create the local variables which are specific to those environments. Now here we'll also be using the concept of the function called what do you call this function? Okay, so now here we are going to use a concept of using the lookup function in your local variables, and I'm going to show you how exactly it is done. So first thing that we are going to do is, in our previous project, which was EC2 Workspaces project, I am going to my main.terraform folder, and in here in the local variables I'm gonna create a variable called AMI ID. Now I'm just going to create these variables, and I'm just going to output them for this for keeping this example to the simplest form, right? So the way I'm going to declare the variable is basically I'm saying AMI ID underscore environment, and inside this I am going to create a map of different variables which are related to different environments. Now, if you remember correctly, there is three environments that are present. Three workspaces that are present, which is default, staging, and production. So for default, I'm just gonna give a value saying, let's say AMI ID is some AMI ID underscore default. I'm just making things up here, and we have staging, right? Equal to, we can write AMI ID underscore staging, and we have production equal to AMI ID underscore production, right? So we have created a map of variables for AMI ID underscore environment. Now we are going to create another variable called, let's say we call it AMI ID, right? So we are saying we want AMI ID to be resolved, right? So the way we are going to do is, what we are saying is, we'll look up in this particular AMI ID environment for the value which matches this environment, right? So we have our workspaces created with this names, staging, and production, and we want to use a lookup function so that we supply saying that we want to look up the particular map variable for this particular environment. So the way you'll do is you'll do dollar open close, and you have lookup function, and inside this lookup function you're going to say local dot AMI ID underscore environment, right, comma, and what do you want to look up for? You want to look up for the environment itself, which is going to be local dot environment. So here we have opened and closed the braces and everything looks correct, and let's go ahead and output this particular variable here. So what we can do is we can say output environment specific output variable, and inside this we are going to say value equals local dot no, not like this, open double quotes, inside that dollar local dot we are going to use AMI ID. Now let me explain this to you again. So what we are doing is we are outputting the value of local AMI ID. Now in the real life example, you would send this AMI ID to a specific EC2 instance, and depending on which workspace you are, the AMI ID will be fetched either this, or this. Right here in your example, it would be the real AMI ID, and the EC2 instance we will use that specific AMI ID. The way we are pulling it out is like we are referencing it to this local variable, and this local variable will resolve to one of these based on the local environment, which is our Terraform workspace. So let's go ahead and run this and see what variable will get back here. Now let me open up my PowerShell again, and we are in the same project directory here. Let me clear this, and let me do Terraform Workspace select. Let's go to staging first. All right, so it's switched to staging, and we're going to run Terraform plan. You should see that there is nothing to be changed because we didn't change any of our infrastructure there. Terraform apply. Now you should see the output variable that we have printed there. Once it is done. All right, so you can see that environment specific output variable here is returning us the AMI ID underscore staging. Now let's say if we clear this and do Terraform Workspace select production, and let's do Terraform apply again. There's nothing to change here. It should again show us that the environment specific variable here is pointing to the production one. So you can see here AMI ID underscore production. Now you can apply this concept to many different variables. You can have shared variables, shared variable module, and you can import that module in different places, and you can use that concept to basically share variables across different modules and across different environments. So I really hope that you enjoyed this lesson and you apply these tips and tricks in your project, and let me know if you have any questions so that I can answer them for you. So that's it for this lesson, and I'll see you in the next one. Thank you so much for watching. Hello and welcome back to #learning courses, and in this lesson we are going to see how to create shared environment variables which can be used across different modules in Terraform. So this concept is basically an extension of what we have done in the previous lesson. Now we will create environment specific variables, but we'll also see how we can share these environment specific variables across different modules. So let's get started. So again, I'm going to use the same project. So I'm going to open up this particular folder where we have Workspaces project, and here I'm going to create a new module. So this new module will be our shared variables module, and you can use this module, import this module in different different other components, subcomponents of the main project, and you can share those variables across. So one of the use cases that I can explain to you is, let's say you have a VPC created, or a trying to think what's the best example. Let's say you have set of resources created, VPC, security groups, and AMI IDs, and you want this information to be available in different modules of your infrastructure. So how do we create this? Like, if we create this in main local variables, then you will have to end up passing this from main variable to the specific modules, or you'll have to either let's say you're creating a module which is a part of different projects, right? Not just this project, and different projects, and you don't want your main file to be inputting those variables for you. So in those cases, this shared variables concept will help you a lot. Again, this is you won't find this information out there. This is something which I have figured out on my own, trying to experiment in my use cases, and I really think that this will help you guys to kind of organize your project. So let's go ahead and get started. So I'm gonna create a new folder in here, and which will be my new module, which I'll call it as shared_vars. And inside this, I'm going to create a new Terraform file, which is going to be shared_vars.tf, right? So yes, I want to change this. Now I'm going to go back and open up the open up my project folder here. All right, so now our shared vars module has been created and ready to use. Now let's go ahead and change our code so that we can create some of the shared vars and use it across different modules. So what I'm going to do is let's use this concept of using this local environment, and we'll use the same concept from here, right? So let's copy this part. Actually, let's copy this entire part from here and paste it in here. Now this local environments Terraform workspace will be propagated to all the modules, so you don't need to worry about it. And here what I'm going to say is, instead of using the AMI ID underscore environment, what I'm gonna call this is EC2 Instance underscore name environment, and I'm going to use the same name here and call this the same thing, and here I'm gonna call this as the environment. Now to make you understand what I'm doing here is, basically we are saying oh no, we have to kind of, let me finish this up so that I can explain what I'm doing here. So what we are doing here is using the no, actually let me do something else. So let's do, because we want to provide an example where we can leverage this across different modules, right? So what I'm gonna do is environment underscore suffix, right? And we can call the same thing here, EnvironmentSpecific underscore environment, kind of redundant name. We'll just take this off here, take this, put it here, call this and we're gonna call it this, right? So what I'm trying to do is basically create an environment suffix, which will return back saying staging and staging and prod, right? So let's do this, and what we are going to do is this is just like what we have done in the previous example, where we have a local variable which is environment suffix. When you call this variable, it is basically doing a lookup on the local environment suffix environment map, and here it is looking for whatever the local environment is. So the environment is mapped to that workspace that you are selected. So if you're on staging, it's going to map it with the staging map inside that variable, and it is going to assign it to the environment suffix. And here what we are saying is, like, we want to output environment suffix, and the value that we want to give it is basically the local environment suffix. So that's how we are exposing this particular environment specific variable to a different module, right? So let's see how we can go ahead and leverage this particular output variable in other modules. So I am going to now go to the EC2 module, EC2 module, and change a bit of code here. So instead of importing the EC2 underscore name from here, what we are going to do is basically we will import the shared vars module into this particular module. So the way you will do it is using module and give it a name. We are going to give the reference name the same name as the module itself, and we have to give the source. The source is basically you have the shared vars module like one step above this folder. So what we have to do is go .. and you have to specify the name of the module, which is shared_vars, right? So now your module has been imported, and you want the EC2 name variable to be declared. So in the previous examples, in the first example, we have taken this as an input from the main.tf. Now instead what we'll do is we'll say variable underscore no, we're going to say default equal to inside this you have to do $ open close. We have to reference to module dot shared_vars dot environment_suffix, right? So what we are saying is we want to fetch the suffix from this shared vars, and we want to append to the name of this EC2 instance. So we are calling EC2 underscore name underscore instance, right? Instance, and we are changing the basically EC2 name here, tag value, right? So that is pretty much done. And the other thing that I want to show is like how we can use the same variable in another module. So let's go to the share security group here, and let's call it the SG name, and we are not taking this as an input, and we can say default equal to, before this we have to import the module. So the way you'll import is again module, give it the reference name shared_vars. Inside this you are going to specify the source, which is one step above from this folder, and it's under shared vars. And once you are imported, you are going to give this the name as SG underscore name underscore, and you're including the vars module dot shared_vars underscore environment_suffix, right? So now you have this name. Now as these names are changed, the security group will be recreated, but the EC2 instance, it will just be renamed with our previous resources that were created. So the other change that we have to make is in the main.tf, because here we don't want to specify this input variable anymore, right? And we don't want to specify this SG name anymore from here, right? So we took those two things off. And now let's go ahead and run the Terraform in the PowerShell prompt. So let me clear this off. Now what we need to do is, first thing is to run a Terraform init, because you have added new modules to your project, so you have to do a Terraform init. Alright, so there is something wrong that we have done. So it's saying variable sg name default may not contain interpolations. Alright, so okay, so what we'll do is, it's complaining that we should not give default equal to something. Alright, so we can do one thing. We can directly apply this name here instead of the vars, right? So we have EC2 instance name, shared module vars, and we can just get rid of this variable from here, and we can do the same thing for security group module here. So we can take this name, and instead of name here, we'll just take it off, and we'll just save it, right? So that should be pretty much it. Now let's go back to our PowerShell, clear this, run the Terraform init. Okay, now we don't have any errors. We can do Terraform plan. Now you should see that the EC2 instance is updated, and the security group should be recreated, and it should be destroyed. Yeah, so that's what we see. So we are destroying the security group and recreating it, and we are changing the EC2 instance. Now if you see, we are updating the tag to instance name changing. This is the new name that we have given it, and we'll be giving it the new security group ID once the security group ID is created, and it will be assigned to this. So what I figured was, like, this would fail on creating the security group, because there should be at least one security group assigned to the EC2 instance, and we are trying to delete and recreate that security group, which would create issues for us. So what we're going to do is, instead of deleting and recreating it, what we can do is, how do we show this example, right? So what was the previous name that we were supplying here, right? So let's try to replicate the same thing. So we were giving sg underscore ec2, right? So let's do the same thing here, sg underscore ec2, and inside this, let's do sg underscore ec2, and we can modify these guys so that it gives us production, right? So now if we go to the EC2 module here, security group module, and let's get this here and give the name here. So there should be no change, because we are using the same exact previous one. So now if I go back and run this Terraform plan, there should be only one change, which is the EC2 instance updation of the tag. And why am I still seeing Terraform course SG2 Terraform? SG underscore EC2 underscore environment suffix, right? So environment suffix here is giving us staging. So there we use uppercase, lowercase, right? So that's why it is creating a problem. So now if I run this again, now I should see only one change. All right, there we go. So the issue here was we didn't want to recreate the security group because it every EC2 instance need to have at least one security group in place, because when you update the name of the security group, it tries to destroy that and recreate the security group, which would not be possible because it wouldn't it couldn't delete the security group because it's already assigned to EC2 instance, so it has to detach it, but there is no other security groups and it will fail. So what we did was like we hacked our code so that our environment suffix would give out the will give out the same name like as it was there in the previous example. So once we do that, it's working as expected. Now we can do a Terraform apply and supply yes. Now our name of that EC2 instance will be updated. Yes, so that has been updated and changed. Now we can clear from here and we can do Terraform Workspace, select production, and we can do Terraform plant. And now again you have to see just one change here because we are just updating the name of the EC2 instance. And you should see that the instance name is changed from EC2 instance production to EC2 name instance production. And we can do Terraform apply and give it a confirmation of yes. All right, there you go. So both the resources in QA and in staging and production have been changed. Let's go back to our EC2 console and verify if those changes are reflected or not. So let's go back here, and if I refresh, you should see that the name should now be updated to EC2 name, instance production, and staging. So this is how you can have shared variables concept separated in a module, and you can reuse that shared variables across different modules within your project or across different projects. So I really hope that you enjoyed this lesson, and if you have any questions or if you think that I did not explain any specific parts of this lesson clearly, you can ping me in the course and I will be happy to explain the concept to you or like clarify your questions offline. So that's it for this lesson, and I will see you in the next one. Thank you so much for watching. Hello and welcome back to another lesson in #learning courses, and in this lesson we are going to do a quick recap of what we have covered in this particular section. So in this section of Terraform course we have covered a lot of ground on advanced topics. We have started with looking at like what modules are, and then we have created our first module, and we have then created multiple modules, and then we had seen how to provide inputs to the modules and how to share the values that are created in one module and export it to the person who is calling, the Terraform script which is calling it, and passing that information along into another module to kind of create those dependencies. And after that we have covered what workspaces are, how you can create different environments using the workspace concept, and also we have covered a lot of ground on how you can create environment specific local variables, and how you can create a shared variables concept, and so on and so forth. I really hope that you enjoyed this particular section, because most of this is all uh, is not covered in the actual Terraform documentation, and I kind of figured out a lot of these topics by kind of trial and error way, and I really enjoy sharing this information with you all, because I'm really excited that you'll be using this in your workloads. And let me know if you have any questions related to these particular section, and I'll be able to answer them through the course. So that's pretty much it for this particular section. In the next section, we are going to create the whole production level infrastructure using Terraform, and I'm going to show you step by step how to create. Like, we're going to create the network, we're going to create the 3-tier architecture, and I will give you more details in the next section's introduction part. So that's it for this lesson, and thank you so much for watching, and I will see you in the next one. Bye bye. Hello and welcome back to another lesson in #learning courses, and this is going to be a really exciting lesson, because we are going to discuss about the AWS project that we are going to build using the Terraform, and we are going to apply all the concepts that we have learned so far in the course, and we are going to see how to create a production grade infrastructure with multiple environments using the Terraform. So in this lesson, I'm just going to give you a walkthrough of like what different components that we'll be creating using Terraform, and how the sample infrastructure is going to look like, and the architecture diagram of it. So first thing that we are going to do is basically we are going to use a default VPC, which will be created in by default in every AWS region. If you have an AWS account, every region has a default VPC and default subnets created for you, so you don't have to worry about creating the new network setup and so on and so forth. If you wish to do so, you can actually go ahead and do it. It shouldn't be really difficult. If you want more information about how you can provision a production level infrastructure, I have another course you can go ahead and check out in my courses, where you'll find like setting up production infrastructure in AWS, and I've also put in a lot of Terraform material there in that course as well. So for this project, what we are going to do is we are going to use, like I said, we're going to use the default VPC and default subnets, which are already created, and the route tables and everything. So we're not going to do a lot of network setup. The only thing that we are doing in the network part is basically creating the security groups. We're going to create 2 security groups. One is for the load balancer, and one is for the EC2 instance that the sample application will be running. So that's one thing. The second thing is we are going to create an application load balancer, and we are going to create one target group and a listener associated with it. When we go to that section, I'll kind of like expand on like what are the subcomponents that are required in that particular module, so you don't need to worry about it. And the third thing that we are going to create is the launch config with user data. So basically this user data is to specify what commands it needs to run on the boot time, and the launch config is basically a platform where you'll create the configuration and give it to the autoscaling group, which you'll be creating in the next step. And autoscaling group will actually use this launch config as a template of like what the autoscaling group needs to launch, and all the properties like which instance, which AMI, and so on and so forth are actually supplied in the launch config, and we'll be using that with the autoscaling group. And once we have this entire setup completed in one environment, we'll boot up the production environment. I mean, we are going to create 2 environments. One is staging and one is production. And when we create the staging environment, we are going to do step by step, and at the end what we are going to do is like just run the same infrastructure for a new production environment, and we are going to see how it is managed. So here is the reference architecture that we are going to use for this project. So this is how it's going to look like when everything is created. Like I said, we are not going to create the default VPC the VPC and the network part, because the default VPC is already created in every AWS account and in every region, and the default subnets are also created for us. So for the purpose of this project, we are going to use, I am going to use the Oregon region. You're free to use any region that you would like to use. So that's pretty much it about the architecture. So let's get started. So I'm really excited to complete this AWS project, because this will give you a complete exposure of how you can handle a complex infrastructure and how you can modularize your infrastructure into different modules in Terraform, and how you can manage your project easily and in an effective way and in a maintainable way. So I will see you in the next one. Thank you so much for watching. Hello and welcome back to another lesson in #learning courses. In this lesson, we are going to do our first part of the project, where we are going to first set up the folder structure for our project and the base modules that we needed, and we are going to create our security groups, and also we are going to set up our first workspace, which is going to be our staging environment. So let's get started. So the first thing that I want to do is go to my course folder and create another project here, right? So I'm going to name that project as AWS, going to call it AWS course project, right? And inside this, I want a main.tf Terraform file. Now, like we have seen in the previous lessons, this is going to be our main Terraform file, right? So once this is created, then I want to create a module called Shared Vars, and this is just like what we have used in the previous section. So I'm gonna create shared underscore. Let's use dash. Did we use dash or did we use underscore in the workspace project? Shared underscore var. So we're gonna use the same thing here, just to be consistent with what we've done so far. So shared underscore vars, and inside the shared underscore vars, we are going to create another Terraform file, which is going to be shared underscore vars .tf. Now this shared underscore vars will hold the variables like the regions or subnet IDs or the VPC ID and AMI ID and so on and so forth. So we'll just create a shared vars here. So the next thing that we want to create is basically a networking module, right? So inside the networking module, let's go ahead and create the security groups that are required for this particular for this particular project. So I'm just going to call it network underscore module, and inside this we're going to create another Terraform file, which I'm going to call it network underscore module, right? Oh, the extension should be .tf. And so the next thing that we are going to create here is basically a okay, so let's create the other modules when we get to that point. So for now, I think we should be good enough, because we have the shared vars and we have the network module, and we can actually get started. So I'm just going to open up this particular folder inside the Sublime text. So let me pull this up here. File open, not file. We want to open the project folder. I'm opening this project. Okay, so now that this is open, now what we're going to do is inside our main.tf file, we are going to basically create a provider. So the provider, how do you provide it? Basically, you call it provider, and you open close this brace, and you're gonna say the you have to give the provider name, which is AWS, and I'm just going to use the same profile name that I've used so far. So I'm going to give it profile equal to sratan-terraform course, and I'm going to specify the region as I think it is US West 2A, but let me just double check real quick. The region that we are working is Ohio, So we'll have to quickly recheck recheck the region. So it is US East dash US East 2. Alright, so that's going to be our region for this particular project. Alright, so now that we have supplied the project, the AWS provider profile and region, let's go ahead and key in some shared vars so that we can use for this particular project. So the first thing that we want is the VPC ID. So to do that, what I'm going to do is I'm going to set up the local variables here, right? So like we have seen in the previous example, so we're gonna call it locals, and we'll have an environment variable as Terraform.workspace, right? So that's what we're going to fetch from the workspaces, and here we're going to say VPC ID underscore environment equal to this is going to be a map, right? So inside this map we are going to have default equal to something, staging equal to something, and we have production equal to something, right? So let's fill in those values from our EC2 console. Now, like I said, every default environment will have every default VPC would have been already created in every AWS region. All you have to do is like go to services and VPC section, and under VPCs you should see your default VPC which is created for you. Now what I'm going to do is like I'm just going to copy this VPC ID and I'm going to paste it here. Now for the purpose of this project, we are going to host our staging and production environment in the same VPC. In your case, it might be different because usually they separate it out, but I don't want to overcomplicate by creating all the network components here, and it was really not the scope of this particular project. So I'm just going to leave it aside. So we have this local environments, and the next thing that we have to do is we have to have a lookup function declared. So this is going to be the lookup. So the lookup is going to be basically under double quotes. We have to open up this and we have to do lookup, and inside this we have to specify local dot VPC ID underscore environment, and inside this, there shouldn't be any equals to there. So local dot VPC ID environment, and we want to find the local dot environment and map it to hit. So that's one thing, and we want to also output this variable as output. We want to output this as VPC ID, right? And we want to give the value equal to double quotes, we give this as VPC local dot VPC ID. All right, so we have our first environment, first local variable created here. Similarly, we need to create the subnet IDs, right? So you want to choose the subnet. All right, so here we need public subnet, let's call it DMZ public subnet ID, and let's give the same thing here. This is going to be public subnet ID, and this is going to be public subnet ID, and here we have to get the public subnet ID. So basically what I'm going to do is, like, by default there are 3 subnets that are created. I'm just going to choose like A and B as my public subnet and the private subnet. So I'm just going to copy this ID, which is to A, to be the public subnet, and so I'll copy this guy, paste it here, and save it. And I'm gonna call this as private subnet ID, and I'm going to use this variable here, and here, right? Okay, so we have to copy the subnet to BID from here, and I'm going to paste it here, and here. Alright, so now we have VPC ID, public subnet ID, and private subnet ID. And the next thing that we would probably need is, let me think about it. So we have VPC, we have public subnet, we have private subnet ID, and what else do we need for the security group? I think that's pretty much it. So what we're going to do now is go to our network module, right? And we have to create 2 security groups. One is for public security group and another is the private security group. So what we are going to do is now go to our previous project, and I'm going to copy paste the security group module that we have created in the previous part, and I am going to copy this here, paste it, and I'm going to replicate it, right? So we have now AWS security group being created, and we have the name should basically, I mean, this is a reference name, so we are going to give it public SG, and we are going to call this private SG. And ingress, we are going to say from port, we just accept traffic on port 80. We're gonna accept the traffic of TCP port, right? So TCP port 80, and we want to this is basically public security group, so it's gonna take in from everywhere, and egress is basically again port 80 to port 80, and TCP to everywhere. So this is going to be our public security group, and we can give the name as public SG. Oh, we have to include our the shared vars module here first. So the way you'll do is module shared underscore vars, and inside this you're going to give source equal to dot slash because you have to go one step above and fetch the shared underscore vars from here, and you can actually get the let's also output the in the previous step we forgot to output the public and private SG values, not the SGs, I mean the subnet values. So we're gonna go give it public subnet ID, and we can give here that this is going to be private subnet ID. Okay, and we want to output the environment variable too, right? So we can call it environment suffix, and we can call it local.environment, right? So we have all these things being outputted from here. Now let me go to my network module, and here I should be able to get module shared vars and environment suffix, right? So that would be created here. Description is public security group for load balancers. All right, in we can give the environment suffix again. Here we can copy this guy, and I'm going to paste it in here. We can say public SG for ELB. All right, so the VPC ID, right? So we have to get the VPC ID again from the shared vars. So again, I'm going to copy this particular part, which is module.shared vars, and the VPC ID. Let me just quickly check. From shared vars, it is VPC ID. So yeah, so it's going to fetch it from there, and this should be now created, the public SG. So now for private SG, what we want to do is we want to accept the traffic from just this security group. So egress would be outside to everyone on port 80, TCP to everyone, and egress port 80, and the instead of CIDR blocks, I think this will be security groups. Security group. Let me quickly double check in the Terraform documentation what the so let me open up the Terraform IO. Let's look at the docs, go to the providers, AWS, and look for the security groups, security group, and we have to search for VPC ID, name, value. This is the data sources we want. So we want this AWS security group rule, and inside that we want to be resource security group. Yep, so we want to copy this security group ID, and we want to ingress from there. So here we will supply saying that dollar $AWS security underscore group dot, this is going to be public SG dot ID. Now let me explain you what I did here. So basically what we are doing is for private SG, that which is going to be attached to the load balancer, what we are going to do is we are going to create the security. We want to just allow the traffic which is coming from the public SG, which is going to be our load balancer, and we want to output it for everyone else. So this is just like a security measure, and the name would be, again, I'm just copying this part so that I can easily replace this part. So I'm going to call it private SG, and this is going to private SG for EC2, and this is going to be the same resource here. So I think we are pretty much in good shape with the security groups part. Now let's go ahead and execute this, right? So to do that, first we need to include this module inside our main.tf. To do that, what we have to do is module, we want to include network underscore module, and inside that we're going to give the source equal to dot slash network underscore module. All right, so now we have everything being set here. The next thing that we have to do is open up our PowerShell. Let me open it up. So alright, so we are in this course directory. We need to go to cd AWS AWS project. Is that what we call cd AWS course project? Alright, so I'm gonna clear from here. So the first thing that we want to do is like create the Terraform workspace, right? So I'm going to do Terraform Workspace, new. I'm gonna call it staging, right? And I am going to create Terraform Workspace. No, I'm just gonna do Terraform init. Now it's going to initialize all the modules that are included here, and it's going to download the AWS plugin which is required for this particular project. Okay, so now the Terraform is initialized. All we have to do is do Terraform plan. Now you should see that the two resources being created, private SG invalid known key security group underscore ID. All right, so let's go back and fix that particular piece. So this is going to be in the network module. I think we did something wrong here. Security group ID, right? So let me go back to the documentation here. Security group ID to allow or access from on the type cannot be specified. Oh, okay. Source security group ID, right? So let me see if there's an example here. So what is this? Security group rule. Oh, we're not doing security group. Are we doing security group rule here? No, this is just a security group. So I think we copied from the wrong direction, wrong place. Okay, AWS security group. Now this is the data source. Alright, so we have to select this guy, and inside this cider blocks, prefix list IDs, we should also have protocol security groups, right? So this should be inside the list. My bad, sorry guys. So this should be a array of security groups that you can allow, right? And now let's go back and do the Terraform plan again. Hopefully there shouldn't be any errors. All right, so we are now creating two security groups, and let's go ahead and do Terraform apply and type in yes. Alright, so now our security groups are created in our staging environment. Let's go back to our AWS console and just verify that if our security groups appear here or not. So I can go to the EC2 service, and under the network and security, you should see security groups. Select that, and you should see that we have created private security group staging and public security group staging. And you should see that the public security group has rules 80 inbound and 80 outbound, and we have the private security group staging, which is just taking the inbound connections from this public security group staging, and it's going to allow all the traffic outbound from this particular instance. So I think we have covered a lot of ground in this particular project. We have completed our network module. Now, as and when we require more information, we'll be adding to this project in the next lesson. So that's it for this lesson. In the next lesson, we'll go ahead and work on creation of the load balancer and target groups. So I will see you there. Thank you for watching. Now, if you have any questions, you can always send a message to me on the course, and I will be happy to answer all those questions. Now, I'll see you in the next one. Thanks. Hello and welcome back to another lesson in hashtag learning courses. Now, in the previous lesson, we have covered a lot of ground in our AWS project. We have set up our folder structure, we have created our workspace, and also we have created our shared groups module, and we completed the security groups part where we have created two different security groups for public security group and private security group, and one is for ELB and the other is for the EC2 instances. Now in this module we are going to go ahead and create a module for our load balancer, and we are going to create all its dependencies. So the list of components briefly are basically the AWS application load balancer, followed by a AWS HTTP listener, and then we are going to create a target group along with that. So let's get started. So the first thing that I'm going to do is go ahead and create a module. To create a module, just like what we have done in the previous examples, go ahead and create a new folder within the same project folder, and I'm going to call it as load balancer underscore module. You can call it whatever you want, which fits your use case. Now I'm going to make another Terraform file here. Just gonna call it load balancer underscore module, right? Oh, I missed the extension here. It's going to be .tf. Now I'm going to go back to my Sublime text here, and I'm going to open up this particular file. So let's go ahead and check out the terraform.io site to get all the information that we need for building an application load balancer. So here's my Terraform site. I'm going to go to the documents, provider, AWS, and let's search for the ALB, right? So it's going to be EC2 resource ALB, right? So let me open this up in new tab, and inside that here's an example of that, right? So let's just copy this part from here, all right, and let's go ahead and paste it in here. So this is the AWS LB is it application load balancer? AWS ALB. Did we open up the same one? Or AWS LB? Okay, I suppose it's called AWS LB here. Okay, so it says here it's application load balancer. So let's go ahead and edit this particular part so that it fits our needs, right? So we're gonna call reference this as our sample app underscore ALB, right? And the environment specific name. So even before starting to include the environment specific names, what we're going to do is include our shared vars module which we have created. So I'm going to do module shared underscore vars, to give it in double quotes. I'm going to call it shared underscore vars, and inside this we're going to give the source equal to, again, dot slash, because you have to go to one level up, right? Once you have that, we can give the name as sample app underscore ALB underscore, give the environment suffix. So it's going to be shared underscore vars dot no, this is going to be module dot shared vars dot environment underscore suffix, right? So did we call it environment suffix? Yeah, environment suffix. Right, so we are saying internal is false, which means it's not an internal load balancer, it is exposed outside, and load balancer type is application load balancer, and we need to specify the security groups here, right? So to get the security group ID, what we need to do is we have created the security group in the network module, so we have to output that security group. We have to output that ID from the network module, and we have to supply it as an input from our main module. So let's go ahead and edit our network module to actually output them, right? So we are going to output the, let's output both private and public because we might need it in the next part when we are doing autoscaling group, right? So let's do output public SG underscore ID, right? And we're going to give it a value equal to dollar. This is going to be AWS security underscore group dot public SG dot ID, right? So let's copy the same thing from here and paste it here and rename this as private SG ID, and I'm going to copy this here and paste it here, right? So we have these two output variables. Now it's going to call public SG ID and private SG ID. So in the load balancer module, we basically need the public SG because it is the external facing. So I'm just gonna call this guy as, we'll take an input as public SG underscore ID and open close. Now when you supply a blank here, it's going to treat it like an input variable. Let's put it to the top so that it's well formatted. All right, so we are going to get this as the input, right? So here the security groups, we need to just give this as var dot public SG underscore ID, right? And the subnet IDs, that's what we want from the shared group, right? Shared vars. So shared vars, we want the public subnet ID, which is our public subnet ID. So we can copy this, we can go back to our module, we can say this is basically module dot shared underscore vars dot public subnet ID. So we got the subnet ID from here, and we got the security groups ID here, and we want to enable the deletion protection. This is like to prevent from accidental termination. It's going to delete any application load balancer, you have to go back and disable this protection and then go and delete, just to be sure before you're deleting anything. Now for the sake of this example, we are not doing the access log, so I'm just deleting that part, and I am going to have a environment specified here as a tag, and we can call this as the whatever the environment suffix that we have, right? So it would be either staging or it would be a production environment. All right, so I think we have a good good starting point as our application load balancer. So the next thing that we need for this application load balancer, let's go ahead and run this before we go ahead and confirm like everything is working fine. So the next thing that we have to do is go to the main.tf, and here what we have to do is include the module, what's that, load balancer underscore module, and source equal to / load balancer underscore module. All right, so we have this part ready, and we need to supply it a input, right? So the input that it is expecting is the public SG ID. So go back to main, public SG ID, you'll be getting it from the so here you have the module dot network underscore module dot public SG underscore ID, right? So you got the public SG ID from this network module, supplied it as an input, and this load balancer module takes it as an input here, and everything is set here. So let's go ahead and execute our Terraform code. Let me clear this. First thing that we have to do is initialize our project. Okay, something is wrong here. So it's saying unknown root level key public SG ID. Okay, so I think, yeah, so we didn't specify that it's a variable, so we need to specify it variable and clear, do a Terraform init. Alright, so our module is now initialized. Clear from here, do a Terraform workspace, select staging. I think we are already in staging, right? So let's do a Terraform plan. Okay, load balancer module only alpha numeric sample app underscore ALB. Sample app underscore only alpha in the name, right? I think it's not liking the underscores. Let's give the hyphens and see if that accepts it. Alright, there we go. It's actually accepting that hyphens instead of underscores. So we have all the defaults and some of the inputs that we have supplied, and now let's go ahead and apply these changes. So we're going to do Terraform apply, and we are going to say yes and confirm it. Alright, so at least 2 subnets in 2 different availability zones must be specified. Terraform does not automatically roll back. Alright, so I think we've got a problem here. At least 2 subnets in 2 different availability zones must be subnet. Oh, okay. So, alright, so let's use the another subnet, which is 1C, right? So we'll use 1C as our subnet 2, right? So let's go to our network module, and not network module, I mean the shared vars, and publics. Let's call this public subnet ID 1, and let's also create the ID 2. We need to supply it here as well, 1, 2, and we need to public subnet ID. We need to make this as 1 ID 1, and we need another public subnet ID, which is going to be public subnet ID 2, 2 public subnet ID 2, right? And we can fetch these from the VPC module. Go to your subnets. Now we've already used 1A as our 2A as our public security group 1, and we have used 2B for our private security group. So let's use 2C for our public subnet 2, right? So let's go ahead and give the public subnet value as this guy. Let me replace this here. Alright, so now we have these things created. Now the next thing that we have to do is right, did we use public subnet IDs anywhere in our network module? Public subnet ID, public SG, we had a. Alright, so this is a VPC level thing, so we don't need to worry about it. So we can go to our shared vars, the load balancer, and here in the subnets we can give one more subnet here, and we'll have public subnet 1, and we'll have a public subnet 2. Alright, so now if we go ahead and run our Terraform plan again, error parsing load balancer at 12.105. So 12 105. Oh, I missed this double quote there. Now we should see load balancer being created. Clear Terraform, apply, supply yes. Alright, so it's taking a couple of minutes to create it. Meanwhile, let's go to our console back and see if something is getting provisioned. So if I go to my EC2 service and go to the load balancers, I should see something coming up. Alright, so my sample app ALB staging is being provisioned now. That's why it's taking a minute to actually create the load balancer, because it is still in provision state. So now that this is being created, let's go ahead and start writing up the other dependencies that we have that we need to create for our project to work properly. So the next thing that we need is basically the listeners. Now if you see here, we don't have any listener, right? So we have to create a listener for this particular application load balancer. So let's go to our Terraform documentation, and you can see that there is something called AWS _ALB _listener. Now let's open up that documentation and see how to create a specific listener, right? So we have some example here. All right, so let's just grab one of the examples here and modify it to fit to our needs. All right, so I'm gonna copy it and I'm gonna call it I'm gonna call it HTTP listener 80, right? Makes sense, because we are listening on port 80. So the load balancer ARN here would be AWS _LB dot this name, right? This is the name of our load balancer reference, and the ARN, and the port would be HTTP is on 80, and the protocol would be HTTP, and we're just going to keep in whatever the security SSL policy is. We'll just leave it there. We don't need a certificate ARN because we are not doing HTTPS. If you are doing HTTPS, you can go to certificate manager, create a ACM cert for your specific domain name, and once you have that cert ready, you can key in your ARN into this particular block here if you are doing HTTPS. Now we are not doing HTTPS, so we are just doing that part. And the next, what we are doing is, like, we have a default action which we need to supply a target group. Oh, actually, my bad. So first we need to create the target group, then we have to create the listener. This is completely my bad. Don't get confused. This is not that of a big deal. All we have to do is now comment this out. So I'm gonna comment all of this out, and we can go ahead and create our target group first. Now before that, let's go ahead and see if it's completed. You can see that the resources are successfully created here, and now let's go ahead and check out the target group documentation in Terraform. All right, so there we go. So here's the target group. All we need is to specify this particular guy, copy this example, paste it in our module, right? And I'm going to call it HTTP sample app HTTP target group. All right, and I'm gonna call the same thing here, but I'm gonna call it sample app dash HTTP dash target group, and we needed a port 80 and HTTP, and we need the VPC ID, right? So where do we get the VPC ID from? We have it from module dot shared vars shared underscore vars dot VPC ID, right? So we have that, and let's go ahead and run this and see if we got our sample target group created or not. Meanwhile, you can also go ahead and check the other properties that you can specify. I mean, the health check, stuff like this. Or we can just leave it as default. The default health check is anyways the root level, so I'm just gonna leave it as is. If you want to specify anything specific to your target group, you can go to the Terraform documentation and figure it out from here. Alright, so for this example, I'm just gonna leave it as is, and I'm going to go to the PowerShell, clear it from here, do a Terraform init again, clear it, Terraform plan. Now you should see that you are creating a target group, and it is being attached to our application load balancer that we are did we attach it? Yeah, we are attaching no, we are not attaching it to any load balance here. We are going to attach it through the HTTP listener, right? So we can just do Terraform apply, and I'm gonna supply yes here. Alright, so the target group is now created. Let's go back to our AWS console and see if that target group has created. So if you see in EC2 under load balancing, you should see target groups, and you should see our new target group has been created, and you can see that there's nothing registered to these targets, and the default health checks are root level, and we have some basic monitoring being provided here. Alright, so the next thing that we want to do is go to this Terraform and uncomment this listener that we wanted to actually I should have used the, do we have Terraform here? HashiCorp. I don't know, maybe we can just leave it like this. Anyway, so inside the inside our load balancer module, we created our listener module, I mean listener HTTP listener 80, and we have attached it to our simple sample app ARN, and we are using a bunch of defaults. And here default action is basically we are forwarding the all the requests to this particular security this particular target group. Now the way we reference to this is we just call this guy from here and call this guy .arn, right? So once this is done, all we have to do is go to our Terraform again, clear from here, Terraform plan. I should see that a new load balancer is listener is being added to this particular load balancer, and we can just do Terraform apply here and supply yes. Okay, so there's some problem with this. So yeah, so we are just doing HTTP listener, so we don't need to specify the SSL policy because this is not HTTPS. My bad, I've taken it out. Clear it, Terraform plan again, and let's do the Terraform apply again. Okay, so now the listener has been created. Let's go back to our AWS console and see and verify if our HTTP listener has been created. So yeah, so my sample app ALB staging, and there is sample app ALB staging, and listener is HTTP 80, and we have the target group as sample app HTTP target group. Okay, so the one mistake that I think we've made is not giving the name with the environment specific. So let's go back and fix it, because it is really important for us to manage the naming convention here so that we not messing up the maintenance of this particular project. So I'm gonna supply it with $open close and module dot shared underscore vars dot environment suffix, right? So we're gonna edit the name here. I think when we edit the name of a target group, it's going to recreate that target group. And all right, so I think we can go and do a Terraform plan again. Terraform apply. So we are seeing that there's one being changed, one being added, and one being destroyed, because we have to update, we have to destroy and recreate the target group, and we have to update our load balancer HTTP listener with the new target group that we are creating. So I'm just gonna do Terraform apply and supply yes. Error deleting a target group because is currently being used by the listener. So all right, the way we need to fix this problem is we need to first remove the listener, right? So we can do that by commenting this out. Because this is a dependency on this, it cannot delete it because it's already being used here, so it has to delete this and recreate that. So now if we go and run Terraform plan, it's going to now delete 2 resources and add 1 new resource. Now what we can do is now uncomment this again, and Terraform plan. Now you should see the new listener being created, and you can do Terraform apply. The reason we have taken the pain to go ahead and fix the name here, because it is really important to maintain the naming convention right when we are doing it in the beginning phase itself, because later on, if to go ahead and change the name of something to make it all consistent when your production loads are running, it will be really difficult for you to change them, because you'll be disturbing the current production environment, and it's really messy thing. I've been there in that situation, and I will never ever repeat the same mistake again of like bad naming convention and then regretting in the later point. So always make sure that you have your naming convention right in the first place. So now let's go back to the AWS console and look at our target group. We have now staging specified here, sample app HTTP target group staging, and we have our load balancer created and ready. So we have all the components that are required in the load balancing module, and that's pretty much it for this lesson. I understand that this is a really long lesson, but it is really worth it to go through the entire part of this, and I'll highly recommend that you create these resources along with me to be able to practice. So if you have any questions, you can ping me in the course and I'll be happy to answer. So that's it for this lesson, and I will see you in the next one. Thank you for watching. Hello and welcome back to another lesson in #learning courses. And in the previous lesson, we have completed all the application load balancer setup by creating the ALB. We have created the target group, and we have also created the listener for HTTP in our staging environment. Now in this lesson we will create the launch configuration, which we will be attaching to our autoscaling group in the next lesson. So let's get started. So the first thing that we have to do is go ahead and open up our project folder, and inside this we want to create another module, which is going to be a autoscaling module, right? So I'm going to create a new folder and I'm going to call it autoscaling underscore module. All right, so inside this module we have to create a new Terraform file, which is going to be also autoscaling underscore module dot tf. Now once this is created, I'm going to open up the Sublime text. So this was our project file. I'm gonna close all these modules because we don't need at the moment. I'm opening the autoscaling module, and the first thing that we want to create is basically a launch configuration, which we want to use it in our autoscaling group. So let's dive into our Terraform documentation and search for the launch configuration. All right, so we want to choose, is this EC2 resources? Yeah, under EC2 resources we have to select the AWS underscore launch underscore configuration, and here you can basically see that there is an example. All right, so let's copy this example here and let's paste it here. All right, so let's change some of the names here. First thing is we need to include the module, which is our shared underscore vars, right? And supply the source so that it fetches it. It's one level up, shared underscore vars. All right, so now this part is done. We want to configure my app sample app underscore lc. Lc stands for launch config, and the name that we want to give is sample app underscore lc underscore from the shared vars. Let's fetch the shared module dot shared underscore vars dot environment underscore suffix. All right, so we got that. Now we need the AMI ID, right? So we can configure these two inputs in our shared vars, and inside shared vars we want to add one more variable, which is going to be environment specific, right? So let's call this AMI ID underscore environment, and I'm gonna copy it here. All right, so the AMI ID we are going to fetch it from our AWS EC2 section. So we are going to go to the AMI. Where's the images? Yeah, so under images there's AMIs, and owned by public images. Is it private? No. Public, Amazon. It's hard to find from here. The easiest way that I will usually find it is go to launch instance, and I want to select this AMI. Is it this? AMI HVM. No, this we want this AMI. So let me choose this guy, and let me paste the AMI here. Now in our case, the AMI ID, base AMI ID is same for production and staging, so we're gonna leave it like that. But for the instance type, right, so we can choose the instance type is instance type. We can choose environment t2.micro t2.micro, and for production let's use t2.medium. All right, so now we have got our instance type and our AMI ID, and let's go ahead and input those variables into this particular image ID here. So we're gonna say, oh, before that we have to go to our shared vars and output these variables, right? So I'm gonna go to output variables and copy them, create 2 copies, and here I'm going to say AMI ID local dot AMI ID, and same way this is going to be instance type. This is going to be instance type. All right, so let me quickly check if we have got that right. So instance type, this should be just this instance type, and there should be this guy, and AMI ID should be just AMI ID. If you select this. All right, so we fixed those small issues there. Let's go back to autoscaling module. All right, so now we have the launch configuration basic parameters, but I also want to give it the security group, the what do you say, the security group, the EBS volume, and so on and so forth. So let's see if we have any more example here, and also we want to specify the user data here. So resource launch config, there's why isn't there anything here? Anyways, so we have the image ID, we have the name prefix instance, IAM role. I'm not giving any role here, but we need to create the key name, right? So to supply the key name, first we need to create it beforehand. So we have to go to our AWS EC2 console in our Ohio region, and I am going to create a key pair here beforehand so that it is handy. I'm not going to use Terraform for this. Key pairs. Okay, the key pairs is here. You want to create a new key pair. So AWS project Terraform key pair. All right. So I'm going to create this, and I'm going to save it in our let's save it in our course. In our course folder here. All right, and we have downloaded that, and we just need to give it the key pair name. Let's do one thing. Let's also create AWS project Terraform key pair staging, right? And save it here. Let's delete the old one because I didn't do the naming right. So I'm gonna create a new key pair, AWS project TF key pair production. All right, and I'm gonna save it here. Show in folder. I wanna delete the one which doesn't have proper name. All right, so we have that. So once that is completed, what we are going to do is we have to create the shared vars for that. So I'm going to copy one of these blocks and create the key pair name, right? Okay, so you know what? these are really not the shared variables, because you don't usually use AMI and instance type and keep a name in the what do you call, in across the module. So I'm just gonna cut this out from here, and I'm gonna declare them directly within the autoscaling module. So let's create a locals here. All right, and environment equal to dollar equal to dollar open close terraform dot workspace, and here we can kind of have these variables set, and the key pair name we have to just create here. All right, so key pair name, oh no, this is underscore environment, and we have the key pair names as staging and production. All right, so this part is now set. The one thing that we have to change here is we have to get the environment suffix that we can get from either shared vars, or you can even do local dot environment, right? And here the image ID, right? So image ID should be local dot AMI ID, and your variable, the instance type should be local dot instance type, and also you want to specify the key pair. So let's go back to the Terraform documentation. So we need the key name, right? So we'll give the key name equals dollar local dot key name, key pair name, actually key pair name, so key pair name, and we also want to supply the user data, right? So we can supply the user data. Let's see how this is being supplied here. So user underscore data. All right, so the user data, we want to create a file in our project directory, and we want to basically open the file in the Terraform directly. So I'm going to open up the autoscaling module, go back once level up. We can create a new folder here, call it user data, and or we can call it maybe assets, because it's one of the asset. And inside this asset we can create a new text file. We can call it user data.txt, and inside that I'm gonna have a bunch of commands. All right, so those commands are basically, let me pull those up. I've already written a few commands which we are going to use as the user data. So it's going to be just these commands, which will have the default PHP site or the Amazon Linux AMI page being served at port 80. So we're just going to use this as our user data. Now the user data is basically, it is the initial bootstrap script that you can run whenever you are launching a new instance, so that you don't have to go in and configure it manually. So my user data is basically set here, and the next thing that I'm going to do is go back to our Terraform file here, and the way you would call this is basically you're gonna say dollar open close, and inside this you're gonna say file, and file you have to open up, and you have to give it a file name, and the file name is basically the user data path, right? So the user data path is actually a relevant path here, so we're gonna go one back level up, and we're going to go to the assets, and we have to give it user data.txt, right? So once we do this, our user data is now created, and I think we've got pretty much everything that we needed for the launch configuration. I think one other thing that is missing is the security group, right? So you have to give the security group. So security groups, and security groups would be a array of items here. So inside that, we just need to give the security group. So we have to take a security group as an input, not module. So you have to give a variable private security group underscore ID, and this will be outputted from our network module, and we have to input it through the main module into this particular autoscaling module. So here what we have to do is just refer to it as, and give it var dot what's it called, private SG underscore ID, right? So now we are having AWS launch config sample app. So everything is set here. The one thing that is left is basically including this autoscaling module in our root module and supplying it with the input of the private security group ID. So we have to do autoscaling underscore module, and inside this we are going to give source equal to dot slash autoscaling underscore module, and we have to give the private security ID equal to again we have to get this as an output from the network module dot private security group ID, right? So once this is done, the next step is to go to our PowerShell prompt, clear, and do a Terraform init. Now if you have any errors, it's going to point it out here. So far so good, no errors. So let's clear this part, let's do a Terraform plan, and let's see what we come back with. Alright, so there is one error actually. So it's complaining about file opening dot slash assets user data dot txt. The system cannot find the specified path. So we went back one path, one file, one directory app, and did we give it the right name actually? User data, right? User data.txt and assets. This looks right to me. Alright, I think it might be complaining about the slashes here. Maybe let's try this, and let's try to run Terraform plan. Character escape 38. Let's try double slashes. So still couldn't figure out this. So asset ASS ETS assets and user data.txt user data.txt assets slash. So we're going one level up and referencing it as the assets. Oh, maybe we just need to give assets dash user data.txt. Let's try it out. Let's give it this. Alright, there we go. So I think what it is doing is taking the consideration from where it is actually running this script. So it is relative to the root or the main Terraform file. So we just have to give assets slash userdata.txt, and it was taking it. So let's go back and run Terraform plan again. We should see that one resource is being created, which is our launch configuration. You can do Terraform apply. Let's quickly make sure that we are giving the name with staging. Yes, so I can see that the name has staging as the suffix, so I'm good with it. So let's create it and enter yes. And yeah, so the launch configuration has now been created, and now we can go back to our EC2 console and go to the launch configuration section, and you should see a new launch configuration which was created by the Terraform. So you can see that sample app lc_staging has been created. Let's quickly verify if our user data was executed properly. Yes, so the user data has been read properly from the text file, and everything is created properly. So that's pretty much it for this lesson. We have completed our launch configuration, and I will see you in the next one. So in the next one, we are going to create the autoscaling group, and let's see how it goes. So that's it for this. I'll see you in the next one. Bye bye. Hello and welcome back to another lesson in #learning courses. And in this lesson, we are going to go ahead and create the autoscaling group, which is the last piece of our infrastructure. And we are going to use the launch configuration that we have created in the previous lesson, and start booting up the EC2 instances at the end of this lesson. So let's get started. So the first thing that I'm going to do is open up my Sublime text and go to the terraform.io site and search for the autoscaling documentation. So I don't want the data sources. I want something in the EC2 resources section, right? Yeah, under EC2 resources, you should see the AWS _autoscaling group. So we are just going to use this, and here we can copy one of the examples. So I'm looking for what example would be good with the simplest version, because we don't want to go ahead and create all the policies and so on and so forth. All we want is a basic we want a basic resource of autoscaling group. All right, so I think this particular example would be helpful for us. So let's paste it in our autoscaling module, right? So once we are here, we don't want to call it bar, we want to call it sample app _asg, and the name that we want to give this is sample app _asg underscore let's give it so module dot shared _vars dot environment underscore suffix, right? So that makes sense. You want to give maximum size 2, min size 1, and I think we can make this as the local variables, right? So instead of using max, min, and the where's the desired? I think we need the desired size as well. Let's go back to this documentation and search for desired capacity, right? Yeah, it's called desired capacity. So we have to do we also need desired capacity equal to 1. So instead of hard coding these, let's also take these as the environment specific variables, because it's always better to have environment specific variables for stuff like this, so that you can have more control over which environment has how many instances, right? So you don't want to hard code them. So we can replicate one of these and call it this is for ASG min, desired, min, and max. Okay, so let's call this ASG desired, and I'm gonna give this name this, and we want to call, we're gonna give desired 1, desired 1, production we want 2, and for this is ASG min, right? ASG min, ASG min, and we want to copy the same values for the minimum, right? And for max, we can call this ASG max, and we can call this ASG max, ASG max, and here let's copy the values from here, and instead of 1, let's do maximum of 2 and maximum 4 for prod. So we'll have 1 and 1 as minimum and desired for the staging environment, and for production we want 2 instances as minimum and 4 as the maximum for the autoscaling group. Alright, so I think we have the variable set up properly. Now all we have to do is assign it to them here. We're gonna call a dollar open close, and inside this we're gonna call local dot ASG ASG min. Is that mint? Yeah, min, max, and decide. And we're gonna copy the same thing. Oh, this is the max, right? So we have to give max, min, and this is going to be the ASG desired. Alright, so the launch configuration name, we have to fetch it from the previous step. The previous step, the launch configuration was sample underscore LC, sample app. So we will give the same thing here, launch configuration dot sample app dot name, and we need the VPC zone identifier, right? So zone identifier is basically the which autoscaling group, which subnet zone that you want to use. So zone identifier is basically we want to supply the public public subnet ID. No, we need the private subnet ID because we are launching the EC2 instance here, right? So we can get rid of this, and we have to give module dot shared underscore vars dot private subnet ID. Let's verify from shared vars if we are inputting the right one. So we have private subnet ID, right? So I think we got that one right. And the tags here, we can give the name tag, and the value tag we can have as sample app, and underscore we can have dollar module dot shared underscore vars dot environment suffix, right? And propagate at launch, yes. And we can also have environment, we can have again the same value from here. So we're gonna copy it from here, we're gonna paste it here, and we don't need all of these interpolations and all, so we're gonna save it here. Alright, so we have the autoscaling group, we have the launch configuration, we have the zone identifier where we want to launch the EC2 instance, and we have the min and max set, and we have referenced our launch configuration that we have created in the previous step. So I think we are pretty much set here. Let's go ahead and execute it in our PowerShell prompt and see if we are able to launch the new EC2 instance or not. So let's go to our PowerShell, clear it here, do a Terraform plan, Let's hope for no errors. Alright, so it is creating our autoscaling group, and let's try to do this, right? Terraform apply. Now remember, we are just creating this autoscaling group with like the defaults and like the basic properties being set here. Now in your case, you might need to add more stuff like default cooldown period, termination policies, or you can add the lifecycle hooks, and you can have autoscaling policies, scaling alarms, scaling notifications, and so on and so forth. But for this project, we are not going to add any of that. You can check all of the that information in the in the Terraform documentation, so you don't have to worry about it. So I'm just going to supply yes here, and once I do this, we should see that the new autoscaling group is being created. The reason why it takes it's delayed here is basically it tries to launch the instance first, and once it is launched, then it's going to come back with saying the success message. So I'm just going to pause it here and come back once the instance is up and ready. Alright, so now our autoscaling group has been created. Let's go back to our AWS console and see how it looks like, and we'll check it out if our ASG has launched a new EC2 instance or not. So I'm going to go back to our AWS EC2 console. I'm going to go to the autoscaling group. Now you should see a new autoscaling group being created here, and we can already see that there is one instance desired and min and max being set to our properties that we have set here. And you can see in the instances section that it has launched a new EC2 instance in 2B, which is our private zone that we have chosen. And if I go to this EC2 instance now, you should see that it is being booted up. And one more place that we have to check is go into target group and see if this EC2 instance has been assigned to this target group or not. No, it won't be assigned to this target group because we haven't specified attaching it to this target group. So that's one issue here. So let's go back and fix that thing. So all we have to do is go back to our autoscaling group here, and we need to supply the target group. So let's go back to our documentation, search for target group ARNs, right? So we need to supply this target group ARN, and we have to kind of give it here, and we need to fetch this from the load balancing section. So I'm just going to use this as an input variable. So variable TG underscore ARN, right? And we are going to input that here as $open_var.tg underscore ARN. Once that is done, now you have to go to your load balancer and you have to output that variable from this target group. So the way you can do it is create a output variable here, naming tg underscore ARN, and here you can see the value will be this particular thing, target group ARN. This should be under double quotes. So double quotes is done. Now once we output this, we have to input this into the autoscaling module here. So tg underscore ARN. Let me reconfirm if that's the right variable. So if you go here, tg underscore ARN, so tg underscore ARN equals again dollar module dot network underscore module dot tg underscore ARN, right? So once that is done, we have to see that if that runs properly or not. So let's clear this, do a Terraform plan. tg underscore is not a valid module. All right, so let's go back to our load balancer module and look at what our output. So we have our output. Oh, we didn't give it in the double quotes. That's why it complained about it. So right, so we've saved this. Now let's go back and oh, still it is complaining. TGARN is not a valid output of module, network module. Oh no, I made a mistake here. It's not a network module. It is a auto load balancer underscore module. Right, now if I go back and do a Terraform plan, the target group ARN should be a list. All right, so we made one more mistake. Let's clear it here. So this is expecting to be as a list inside the autoscaling. So all we have to do is supply it as an array. Saved it. Let's go back and try one more time. Terraform plan. All right, there we go. So now it's being modified and it is attaching it as a target group to the autoscaling group. So let's do a Terraform apply and supply yes as confirmation. Now once we do this, all right, so one fundamental mistake that we have done here so far is we need to have the availability zones matching with where the autoscaling group availability zone and the load balancers availability zone should be matching. Even though they are in different subnets, it doesn't matter, but the zones are actually important and it needs to be matched. So what we can do is, like, we can go back to our network module and fix them and make sure that everything is aligned, and then we can start using this. So all we have to do is, instead of using this 2B zone, we have to just use one of the 2A or 2C zones so that it starts using this. So let's go back and fix it. It's very easy. All we have to do is go to our Terraform here, and you can see that the zone identifier, all we have to do is use the public subnet 1. Now we don't have any public or private created in our network setup because we are just using whatever the defaults which are available. Usually you create public, private and DMZ within the same two availability zones, and you'd basically have different subnets created in the same zone so that it's all the traffic is flowing in the same zone rather than going cross zone and creating problems. So all we have to do to fix this is change the VPC zone identifier to public subnet 1, and we just have to relaunch the instance so that it starts seeing the traffic. And that's pretty much it. So let's go ahead and clear this, run a Terraform plan. It's not a valid resource from public subnet 1. Is it not the valid one? From shared vars, public subnet ID 1. Alright, so it's public subnet ID 1. Let's go ahead and run this. It's going to update it. I'm gonna say Terraform apply. Gonna do yes. Okay, so that's been applied. Now another thing that we have to do is to launch a new EC2 instance. So all we have to do is change the min and desired to 0 so that it terminates, and then we'll relaunch the instance. Terraform applies. So we are like terminating the existing one and we'll relaunch a new instance now. So apply yes. Okay, So now it's been turned to 0. Now if I go back to my console here and check in the Autoscaling group, we should see that the EC2 instance is being terminated here. If I go here, you should see the instance is being terminated. I'm not sure where the 2A instance came in from. Oh, maybe it has come from our previous execution. So let's just do a full refresh and see if we have any instances left. Okay, so both are getting terminated. So let's go ahead and change our values back to 1 and re-execute Terraform so that new instance starts coming up. We can do Terraform apply and do a yes confirmation. Let's just give it a few minutes and let's go to instances tab, and I see that the new instance has come up in 2A, and now let's go to our target group and see if our instance is registered here. Alright, so we can see that in targets. Okay, so this says it is unhealthy. So I'm not sure why this target group is still unhealthy here. So one thing what we can do is like go ahead and debug what's going on in the instance itself. So if we to do that, we have to go to the instance. All right, now we have to see whether we are able to get a 200 response back from the EC2 instance or not, but we have locked our security group so that it's not allowed for access from outside. So first we have to go and fix the security group to debug, and then we can again close it back using the Terraform by rerunning it. So I'm just temporarily opening the HTTP port to everything just to debug, and now I can go back to my instance, select the public IP and run it. So I do see that my default page has been loaded, but somehow it is not being registered as the healthy target. So let's inspect this guy and go to the network tab to see what response we're getting. If I do a refresh, so for some reason this is returning a 403. This is a default page. I'm not sure why it is returning 403. That's why it is not being registered as a healthy target. So also I see something here from the load balancer, which is from the instance, which is giving a 200 back. So maybe we can use this as the health check instead of just the default. So let's take this and let's fix it in the let's use that as a health check in the target group, right? So what we can do is we can go back to our Terraform, and we have to go to the load balancer module, and here in the target group there should be something called health underscore check, I think, or health underscore check. Let's quickly verify it in the target group. It's called health underscore check. Yeah, that's right. So health underscore check is basically this, and let's go ahead and do a Terraform plan. Health check should be a list. Why would health check be a list here? Health check, this is a target group, sample target group. Why would a health check blocks are documented? Oh, health check is a block. Okay, health check and target type Okay, so health check blocks. So health check is a block, and we need to give all these information into that, right? So we need to give health check is basically a block. So this doesn't have equals here, and instead we need to give it the path variable equals can actually give this path and close it here. All right, so this will be my path, and I can say interval equal to, I want to check every 5 seconds, and timeout, is it timeout? Yep, timeout equal to let's give 4 seconds timeout. Timeout should always be less than the interval. We have the healthy underscore threshold equal to, let's say, 2, and unhealthy underscore threshold equal to 4, and let's make this 10 just so that it doesn't go out too quickly. All right, so now let's try to run our Terraform plan. All right, so it is now reverting back our security group, and it is adding these properties to the target group. So let's do a Terraform apply, and let's see what happens now. Apply yes. So our changes have been applied. Now let's go back to our target group and do a quick refresh here and see if our health check got updated. Okay, so it got updated to GIF here, which should return back the 200 back to this. Now we'll have to wait until like few runs of this just so that it reports back 200. Alright, so after a couple of refreshes, you can see that the target has now been marked as healthy because we have 200 coming back from this particular path. So that's pretty much it. So now we have launched an EC2 instance using the Autoscaling Group, and we have registered the particular EC2 instance to a target group, and we have debugged our EC2 instance by opening up that security group for a temporary debug purpose, and then we figured out the issue, we fixed it, and once we ran the same Terraform again, it actually reverted all my security group changes and got me a clean state. Alright, so one last thing that we have to verify is by going into our load balancers and by browsing the load balancer DNS and to check if our app is being responded on this particular DNS. So I've copied the URL to the browser. Alright, so yes, so we do get back the response from our load balancer URL. So this tells us that our project is now complete. So that's pretty much it for this project. We have gotten all our components created. We have got the autoscaling, we have got the load balancer, target group, and the entire project is now complete. So the last thing that is left in this particular project is now spinning up the production environment using the same script. Now remember, you have got so many problems when you were creating staging environment because that was the first time that you were setting it up. So if you were to set it up all again manually without this Terraform script, now you might encounter many other problems with many other manual errors. Now that we have everything scripted in Terraform and it is like created using the workspaces, you can just create the production workspace, and as we have already keyed in all the production variables. It is as simple as creating just a new workspace and spinning up the entire environment, and I'll show you in the next lesson how you can easily spin up this copy of this environment in within few minutes. So I'll see you there. Thank you for watching. Hello and welcome back to #learning courses. Now this is going to be our final lesson of this particular section. So let's get started. So in the previous section, we have completed our AWS project by creating our autoscaling group and the and booting up the instances and fixing various issues that we had with the availability zone issue, and then the health check issue, and so on and so forth. And finally, we verified it by browsing through the load balancer URL. So now we have completed all these steps in our previous lessons in our staging environment. Now is the time that we have to launch this for a production system, and to do that for a production system, all we have to do is basically create a new workspace for prod and run our Terraform script and see that the magic happens, that you have replicated this entire environment with just one single command. So let's go ahead and get started and run that particular thing. So to do that, first thing that I have to do is go to my Terraform folder, the PowerShell prompt here, and do a clear on from my previous thing. Now I have to do a Terraform workspace new and call it production. Let me quickly verify in the variables whether I called the uppercase P or lowercase p. The best way to check is to go to the shared vars and see that, okay, it's a lowercase p, right? So it's new production, and then select, hit enter, and once it is created, you can see that the workspace is now switched to production. You can verify that by running Terraform Workspace list, and you should see that you are currently running the production environment. Alright, so now the next thing that we have to do is run Terraform init. This is going to include all the modules that we have created so far, so there was no problem. It included all the modules. I'm clearing this. Next thing that I'm going to run is Terraform plan. Now you should see that all the resources that we have created previously, step by step, in staging environment are created in one step. You can see that there are like 7 resources that are being created. One is the Autoscaling Group, we have the launch config, we have the sample app ALB, then we have the listener, then we have the target group, then we have the private security group and the public security group. So let's go ahead and apply this changes, Terraform apply, and hit yes. I might have pressed the wrong key here. So let's clear this, do a Terraform apply, and type in yes. Alright, so now our resources are being created. We'll just give it a couple of minutes. Alright, so after a few minutes, all the resources were successfully created. Now let's go back to our AWS console and verify all our resources are properly created or not. So the first thing that I'm going to do is go back to my AWS console, go to the EC2, and first thing that we have to verify is if we had our security groups created properly. So inside security groups, now you should see that private SG production and public SG production has been created. And after that, we have to go to our load balancer and see if we have a new load balancer created for production or not. So yes, I do see a new load balancer being created, and under listeners, we should have HTTP listeners, and the listener should forward it to a production target group. And if I go to target groups, I should see a new target group for production, and we should see all our health checks that we have configured in staging environment should be applied to production as well. And the next thing that I'm going to verify is going to the autoscaling group and see if the instance is now launched or not. Yes, so you should see 2 instances being launched and the maximum should be 4. Now if I go to the instances tab, you should see 2 instances are created. Now the one last thing that we have to check is going to the target groups and see if the targets are registered to the if the instances are registered to the target group or not. So if I go to the targets, you should see that 2 instances are registered and they are marked healthy. And the one last thing that we have to check is going to the load balancer and browsing the load balancer URL and see if we are getting back a response or not. So I'm gonna open up a new tab and use this. Now you can see that sample app production is also working properly, and this is how you create your Terraform project to maintain your infrastructure, so that you have one specific Terraform script and you run it across multiple environments. Now that's pretty much it. Now we have completed our project, and I really hope that you guys enjoyed building this particular project. I know this was a lot of hands-on, and I really encourage you all to follow along my lesson and create the resources along with me, so that you get a lot of practice doing this type of stuff, and it will really help you in your career, and also it will help you to manage your infrastructure in a better way. So that's pretty much it from this lesson's perspective. One last thing that I wanted to mention was that I'm going to upload this entire project into the course resources, so you can download this entire setup and you can change your variables and you can basically reuse my template to create an infrastructure in your environment. So that's pretty much it from my side, and if you have any more questions, you can always ask in the course, and I'm happy to answer everything. So that's it for now, and I'll see you later. Thank you. Hello and welcome back to the conclusion part of Terraform course, and I really hope that you enjoyed and learned a lot in this particular course. And if you have any specific questions, you can always ask them in the course, and I'll be more than happy to answer them. And for the next steps, I would suggest you to check out my other courses. They are like, if you are a really beginner in AWS, I have a course for absolute AWS beginners course, and if you are a little bit of advanced user of AWS, then I have a course where I have taught like how to set up all the components in a 3-tier architecture, and also some of the Terraform bits and pieces there. If you want to learn specific topics like S3 CloudFront, I have a course for that, and also you can check out my AWS SNS course if you are interested in that particular piece of AWS. So final thoughts, if you have any questions, hit me up on the course and I will be answering them, and I really hope that you continue your journey in learning the cloud technologies. And that's it from my side. Thank you so much for watching. Bye bye.